right? Maybe like the plan what you guys are having and all, right? I know like definitely will take some New Year resolution, and I know like couple of you guys mentioned in your whatever that feedback what that we got right from you of about knowing about your plan and all of what you're going to do next. I found a lot of people have mentioned like by next year I'm going to try like that and all. So I mean like you can think about it even subsequently also, guys, right? It's in the way how you are going to take it forward. But however, as I made you guys understand earlier, right? I have this one dedicated project created completely in the cloud platform. Okay, so I mean I did not realize this project will go into all this extent and all, but I wanted to make it bit simple, right? I don't wanted to complicate it. I wanted all of you guys to try first of all simply without spending too much of time in the environment setting, without spending too much of time in even writing the code. So I made my level best to create this project in such a way you can able to easily take it and make it run and all. Okay. For that, I had to do some nitty-gritty works of creating some steps and view. But however, I mean, like I put a lot of time and effort on building all this documentation and all. That is going to help all sort of people. Like it is not only for a very lower experienced person of 1 or 2 years. It has to help even an architect level person who is going to make use of this project to mention in not directly in their resume, but they are going to take some essence out of this and they are going to understand, okay, this is how an end-to-end project document will be looking like. Maybe I referred some of my older documentation or some of my proposal documents and all, right? Whatever I have given so far, everything I have referred, and I just built this entire project documentation. Almost I completed till this part. I would say the slide number 28 until I have completed the documentation creation for this project. Okay, and subsequently I have few more things to fulfill, right? Few more things to completely fulfill, and I'll do that also and make this project fully maybe like conveyed to you guys in a complete end-to-end automated fashion, maybe in the subsequent weeks. But at least I may need 1 more week of time to complete this entirely. But for now, we'll start with what we have currently, and I'll take you guys with what is the approach that you are going to follow to execute this project, and then I'll maybe like make this project run end-to-end in the one more connect that we are going to do. Okay, altogether about it. Okay, let's get started, guys. So the project name I just mentioned with the different permutation combination of names, where I tried to add some name like analytics, hub, or intelligence or intelligence with bank added in the name altogether. So I taken the banking domain because couple of our team members are in the banking domain, and just wanted to have that domain as a one of the maybe like a domain to consider for this project particularly. Maybe in some other project what I'm going to do, I may take some other domain which where our more number of people are already into. Okay, but this project we'll consider is more related to the banking domain altogether. So Bank Sense Analytics Hub is the name what I'm giving for this project. But one humble request, please don't use this name as is. I'm just giving you an example of this, right? None of this images or none of this content whatever I'm giving you, don't use it directly. Rephrase it. Do some rephrasement, right? Don't use it directly, because think about it. 48 people are attending today. If 48 of you are put the same project name, how it will be looking in your resume? Think about it, guys. So please ensure you are going to give the name, something taken from the names, what I'm suggesting here, or what I have given here, or what I'm suggesting over here. So start with the project name uniquely identified with some terms used. Particularly, I always tell this, right? FinLake, Financial Lake, Data Hub. A hub where you are performing financial data lake creation. Or Bank Sense Analytics Hub, what we are naming our project as. Or Financial Vantage Insight Data Product. Vantage Insight Data Product. Vantage means the data mesh-based data product that we are building. Data product is a term what you are using. Vantage what you are using. Fin means financial, right? Bank 360 Insight Lakehouse. So Lakehouse is the term we are using here. Data Hub, Analytics Hub, Data Product, Vantage, 360 Insight Lakehouse, or I just have this name suggested very long back in my organization for one of the project, right, as ideas. Integrated data warehouse for enterprise analytics and strategies. So the same name I'm using here, maybe rather than integrated data warehouse, I'm mentioning it as integrated data lake or integrated data lake house for enterprise analytics and strategies. So banking based integrated data analytics for data lake for enterprise analytics and strategies is a project name. You can mention as well something like BIDEAS, banking ideas or something like this. You can make it used for. And financial bank enterprise omni data lake, converged data lake for managing the enterprise financial and the banking sector data products like this. I have some suggestions over here mentioned. You can just add more suggestion or more name out of this. You can just build one unique name, guys. Please don't copy this name and put it in any of your project. Very, very important request I'm bringing for all of you. Okay. Keep it aside, guys. The project title could be any one of this or amalgamation of all this or some of the mix and match of all this. You can consider this. It's up to you. Okay. Project name. Project Synapse. I mean, like these are all a bit needed for you to mention in your resume or rephrase this and put it in your resume, right? This project creates an unified cloud native data platform for on GCP using Big Lake architecture. So the architecture what you are using here is a Big Lake architecture, a lake house architecture. You can call it as the market is using this term and all the Big lake house, all these architectures and all they are using in the market. It is understandable. Okay. So Big Lake or lake house architecture, right? Where the centralized structure and semi-structured or unstructured data will be stored, right? It enables bank to integrate the data from different sort of data like credit card or accounts or activities, loans, payments, like what are the type of data we are going to handle, the core data what you are going to handle, I have listed it over here. And it is not the complete list. We have a lot of other list of data that we are going to work as well. Is it breaking, guys, my voice? Only for Ranjit or everybody else? Okay. Ranjit, please check your connection, okay? It could be only for you. Okay, fine. So, the data, what we are going to use for this, for the execution of this project is even unstructured data also. Literally, we are going to use very interesting factor we are going to see today. I mean, like we are going to implement some GenAI based or LLM based or Gemini based or Vertex AI based model inclusion and all we are going to do today in our learning. Okay, as a data engineer, how I can contribute in not working in the data science, but in the maybe like kind of like model building using GenAI. How can I involve this kind of things and all I'm going to include in our today's in this project, particularly as per the modern need of our market, how it is trending and all, right? The prompt engineering and all I'm going to basically cover. Okay, I'm not going to take it as a session or as a concept and all, but I'm going to implement and show you guys directly because that is a big part. However, as a data engineer, as a ingestion developer, as a data engineer, how can I enable or I can use the prompting techniques or the LLM models and all, how I can invoke and I can implement that in bringing the data to our platform. I'm going to show you guys that part very quickly. Okay, so let's go and see that and all. But the data, what you are going to handle is even different in types actually, not only the one what I'm just showing you, right? We are going to handle some image data. We are going to handle some complex JSON data. We are going to handle structured data also. Like all this kind of data we are going to handle. So all three types of data we are going to handle in this project. And it is not only related to the loans payments, it is related to a lot of other currencies, the bank currency conversions, and all this we are going to see, including facilitating advanced analytics for the customer engagement, fraud detection, providing personalized service or understanding the customer behaviors. All this we are going to do through the, finally the machine learning team and predictive analytics team will be consuming this data, right? Where the banking can take actionable insights, addressing complex transactions, reconciliations, and all sort of activities they are going to do, including supporting of real-time and historical data access for making the better decisions, right? where we implemented, or we are finally implementing Lambda architecture in this project. Lambda architecture in this project, which is nothing but both batch and real-time streaming we are going to perform. Okay, let's discuss on that. Problem statement is bank face challenges on managing the huge transactions, performing adjustments on the risk activities happened, or adjustments on the like the amount that has been transacted and all, right? Getting duplicate entries, processing errors, fraudulent activities. With the high transaction data I wanted to collect, like lot of requirement bank has, without an unified data platform of bringing all the data together, which includes credit card data, or loan data, or payment data, accounts data, customer data, and all this data without I bring together in one place, it is very hard for the management of the customer transactions, or it will not help us analyze the historical and live data easily. So the lack of integration limit their capability of generating some insights out of it, managing the risk and all, risk mitigation and all, they were not able to do, and they are not able to improve their product also. So the robust data lake with a centralized data handling platform that we are going to create, that supports in fact the real-time streaming also, is going to help us enable the analytics platform and the data science platform for the better business insight. This is the problem statement what this particular project has. I'm having some diverse data. This is my overall project that we wanted to execute by using GCP or a cloud platform, any one of the cloud. This project we can directly transfer to the Azure platform also possible, but any one of the cloud you consider, right? On top of this, what is the roles and responsibility as a data engineer that I have, right? On top of handling this project, or handling this problem statement. Okay, as a data engineer, or as a lead data engineer, or as an architect, since we are talking about more of technical part of this, right? We are going to concentrate on the more technical part of it. Though I have listed the managerial part, the hierarchy of who are all going to work in this project, the timeline view of how we are going to execute this project, and who are all the stakeholders are going to involve, and what all the activities we are going to perform to fulfill this entire project, and who are all the stakeholders going to work on this. Though I listed out all this in this entire project documentation, our main aim is concentrating towards the technology behind it, right? So as a lead or a data engineer, I'm going to, or a lead data engineer, or a architect, or as a solution architect, I am going to design the robust data architecture and implement an end-to-end ETL process in the cloud native GCP environment, involving integrated data from various sources, ingesting data from various sources, managing the customer interaction data, bank products, purchases, credit card transactions, and everything, payments and employee information, and all the data into our unified data lake environment by building lakehouse on top of it, right? So you can add more points over here. Just I leave it as is, right? As per your wish, you can add on top of this anything, right? So what is our aim? What is our aim of building this product is design a scalable, secured data architecture using the GCP core component like Bigquery, cloud storage, Dataproc for efficient storage, processing, and analytics. Build automated ETL workflow by using Dataflow, Cloud Composer, Dataprep, or Cloud Functions. All these kind of components we can use for building the automated workflows. Maybe Cloud Functions we can use here also to perform that operation, right? For seamless data integration and transformation, or automation as well. Integrate the data from diverse sources into our Bigquery using Bigquery data transfer, or Cloud Functions, or pubsub, including data flow and all for integration. Implement the data quality using data catalog and Dataplex, using IAM, enable the security, manage the storage with the cloud storage, and use for data lake activities and all, for data analytics and all, use Bigquery. Optimization you apply on the Bigquery. mention the data flow auto scaling, use the data flow and Dataproc tuning capabilities and all to improve the performance, enable the report using the Looker Studio and all, right? And then enable the CI/CD pipeline on doing the continuous integration, continuous deployment. Monitoring you can do using cloud monitoring and cloud logging and all. And work with the cross-functional team to provide the data-driven outcome, right? All these are the aim of managing this project, not limited to. We can add more, but I have just added here in the below, like what are all the other activities we are going to perform. This is a high level aim of what we are going to achieve. Technology stacks and the strategies used. This is very important. What are the business strategies, the technical strategies we use here in the entire project? The data ingestion from the file systems, from external sources in the GCS cloud storage we are bringing. We are using Dataproc for doing the data ingestion from data processing. We are using Spark JDBC, or we are using Cloud SQL as a source. We are using Bigquery even as a data ingestion tool from the different databases and all we are doing. Change data capture we are going to do. Slowly changing dimension type 1 and 2 we are going to implement. Maybe in our first project, what we have seen in the Python project, we have used versioning as a concept of implementing SCD type 1 and 2. This time we are going to not use versioning. We are going to use time-based slowly changing dimension 1 and 2 concept. I'm going to deactivate some data. I'm going to activate some data. Active flag or active time and all I'll set. So people can able to understand what was happened before and after this date and all. Such kind of merge feature or update features we are going to use to perform the change data capture, come slowly changing dimension on it. So we are going to create some checkpoint files and all to maintain the last data that we have ingested in the system so far. So the incremental data ingestion will do based on what timestamp we stored on the last ingestion that happened. Until today morning, I ingested the data. I'll store today morning 9 a.m. time in my file. Anything greater than this file value will be ingested further. Not the same data will be ingested again and again. So such kind of incremental data ingestion with the help of checkpointing feature and all, we are going to do. So incremental data, including incremental data ingestion, change data capture, which includes incremental ingestion, data ingestion using file checkpoint. This checkpoint is not a Spark checkpoint. It's a kind of like we are going to store the data into our files for maintaining the last timestamp of when the data got ingested. Leverage Dataproc with Spark SQL, right? Or Hive query. HQL you can write in the Dataproc Spark program. Data storage in GCS and pull the data by using the Spark connector or Bigquery connectors. Visualization, historical data ingestion, historical load come daily load, come continuous load. First we have to load the historical data. So we have to think about how we are going to load historical data. Then enable the live data, enable the hourly data, daily data, or even real-time data. Complex JSON data processing we are going to do. And then we are going to calculate some KPIs and metrics and all using some functions, using the procedures that we are creating. Data transformation and enrichment using Dataproc we are going to perform, or Bigquery we are going to perform. Both Bigquery also we are going to use here. Performance optimization and external table creation for lakehouse creation, data aggregation, analytical functionality, report generation, everything we are going to do in this project overall. Right, these are all the tech stacks and the strategies what you are going to use. Maybe it may be added more here, but whatever I was able to capture, I captured it here. But in fact, like we are going to do, we are going to apply some logic related to the GenAI techniques using Gemini and Vertex AI for computer visioning using or computer visioning of the image data using prompt engineering. These are all the terms you might have heard in the market nowadays. Including this kind of techniques we are going to apply in our this project particularly. Okay. Subsequently, the terminologies that we have used, regular terminologies, push down optimization, change data capture, incremental data ingestion, complete ingestion, multi-line JSON, optimization, data munging, wrangling, boundary partitioning, passing of parameters, configuration, right? Generic framework usage, user-defined function usage, data pipelining, data discovery, data curation activity, analytical functionalities, LLM, GenAI, Vertex AI, or Gemini, or prompt engineering. Almost we are going to apply all this. So this is the broader tech stack and the strategies that we are using, and this is the core terminologies that we can use. What ultimately we are going to derive out of this, the key performance indicators and the metrics, what we are going to derive, not limited to. These are all some of them, not all of them. Some of them. What is the overdraft limit usage of the customer? What are the high value payments made by the customer to send to the RBI and all? Low bank accounts, how many people are maintaining to charge them? How much failed transactions have happened? Excessive fee payment, how many people have made? Or how much the merchants paid to the bank, or within the merchandise, how much they paid? That analysis, customer segregation, suspicious transactions, suspicious accounts, payment reconciliation, right? Heat map of how the account activity is happening. Is there any abnormal activities are happening in the account? Multi-currency analysis of bringing the data from the external APIs, API ingestion and all we are going to do. Fee revenue leakage detection, cross-sell opportunities for high-value customers. If the customers are doing higher transaction, I'll go and target them for doing some cross-selling activity. Clearing system efficiency, how the clearing system is completing the clearance of the money between the system. All these are kind of the KPIs and metrics and the analytical and the transformational functionality we are going to apply in this project, not limited to. I'm not asking you to put all this in your project and in your resume and all. If you bring some of these points in the project explanation and all, you'll get a lot of clarity. Oh, these are all the banks are doing. Not everything is not limited to. We can say some portion of banking activity we are doing. Okay. So the data modeling. We build a data modeling here. The ER diagram has been built here. This ER diagram says what? One of our team member even helped me building this. One of our team member have helped building this data model and bringing some of this data under. Because cooking the data is a very bigger task for performing any project. In an organization, we'll get the real data generated, they'll give us. But we are cooking the data and making the data connected and produces a connected result of all these use case output is not so easy. It's a nightmare actually. That is where it took even long time for making this project completely identified. The coding or other things and all did not take much time. The much time taken is building the data. That considerably some of our team members have helped actually. Okay. Okay, fine. So the data modeling will be done by the data modelers, by the data solution architects. I will talk about who and all have played what are all the roles here. If you see here, the data solution architect sitting here will be helping us building the conceptual data model. They collect the business requirements from the business users, from the business team or from the business users, from the business architect, right? Via the onshore consultant or onshore counterpart, business analyst or business consultant, we will get the data solution architect will get the business requirements based on the business attributes, payments data, accounts data, credit card, customer profile, or currency information. All this data will be collected by the, like our solution architect, data solution architect, and you will create a conceptual data model based on the business requirement and the rules that we are going to apply. We'll create the conceptual data model of what all the tables are needed. At least I have mentioned only 40% of the tables what we are going to use in our project. There are almost 10, 15 more tables are available. we are creating in this project altogether. So if you see here, there are a lot of other tables we are going to put. You see here, potential fraud accounts is a table, right? Reconciliation report is a table. We have the table called exchange rates table, portfolio risk table is there, fee leakage table is there. Like this, we have a lot of tables are available in this entire data model. But this is the ingestion data layer, ingestion data model. For ingesting the data from different sources, these are all the table structures. Based on the business original requirement, the conceptual model of, okay, what are all the tables we needed for our project to get executed will be created by our data modelers, the data solution architect. We don't call them as a data modeler. We call them as a data solution architect, DSA. Data solution architect. So conceptual model represents what? What are the tables we are going to use? Then the logical data model represents what? How many columns, how many attributes, what is the data type, how it has to be joined. The payments and accounts table has to be joined based on the columns such as the account ID. The account ID I can use to identify who transferred the amount of how much from one account to another account. What is the account type he have, and what is the balance amount they have transacted and all. All this information I can connect the payments and account. The transactions and the accounts can also be connected by using the account ID. Customer will be connected with the credit card data. Which customer have made the customer ID, have made the credit card transaction? Which customer have paid the loan amount? Like all this data, we are going to have a connectivity established by the logical data model creation, which is nothing but the ER diagram. ER diagram is nothing but the logical data model. Then the physical data model creation is nothing but defining the constraints, creating of the views, creating of the materialized views, or creating of the physical tables will be done with the help of our platform team or the data engineering team. The physical data model will be created. So I thought of showing how to use Terraform to create the tables and all. I mean, a couple of our team members were asking, Irfan, can you give me some idea on what is Terraform? Terraform is an automation tool for implementing our objects and all whatever we needed. So I thought of showing it in the last session itself, but I was not able to show that. I forgot that, in fact. I have the Terraform based implementation model that is available to create some Bigquery tables or data sets or anything. We can just configure in a JSON format, in a HashiCorp language format files we will be having, HCL files we'll have. Just we had to go and implement the Terraform to deploy the maybe like our tables or structure or data sets or anything in the cloud platform. As an example, I can show you guys. So that implementation in an automated fashion using CI/CD or using scripts, our data modelers or data solution architects will hand over it to the respective team, the technical team, to get it achieved. So these are all the way how the project will be documented. These are all the way how the project will be developed in an organization. And then the implementation plan of this project. What are all the work breakdown structure that we are going to create? This is called WBS. We used to call it as work breakdown structure. The traditional term, we call it as WBS. We have phase 1 to 10 phases we have. First, the data discovery phase, discovering what are all the data sources, how to map the columns, data types and all this, data governance and security, whether we can bring this data from this external API, is it legitimate to bring the data from them or not? Data quality, how much we are going to get, how much columns are going to have a proper value. This assessment and all we will be doing initially. That is phase 1, the data discovery phase. Then the architectural designing, cloud architecture design. What are all the layers we are going to have? What are all the semantical layer we are going to have? What are all the tools we are going to use? The entire cloud architecture we have to design. That is the second phase, including the design data flow diagram, the storage members like raw layer, curated layer, all these kind of things, including the ETL pipeline design, everything we have to give at the very high level. Setup of the environment, data migration, the environment setup, right? Setup come data migration, platform setup, data migration, data transformation, all this. So setting up of the Databricks or Dataproc cluster, what we are going to use here, Dataproc cluster. For batch ingestion, pubsub and dataflow for real-time data ingestion. Source systems, how we are going to establish the connection, how to integrate with them. Set up the data flow for Dataproc for transformation, right? Implement GCS for storage. Set up the data warehouse or data lakehouse by using Bigquery, Big Lake and Big Lake and Lakehouse by using Bigquery. All these activities we do. As a part of this activity, when we perform, clear understanding of what the customer need and understand of the existing system with the compliance for future challenges, risk mitigation and all we can do. Data quality reports we generate, identify the potential risk when we do this project. Who are all involved in this? The client, project lead, project managers, the subject matter expertise, the compliance people, compliance team members, everything will be involved. Architecture design, solution architect, data architect, customer, clients, technical lead, data engineer, everybody will be involving in this. It will go with multiple iteration. Preparation of environment, especially the platform team, data architects and data engineers will be involved, right? Because platform team will be involving on creating the environment, but usage of the environment will be done by the other team. Data validation, testing team, it depends. The testing team is going to be separately work on that, or the data engineers can do handling of null values, completeness data, encryption, or access control definition, right? And then maybe like, do we have any data leakage, data issues, relationship, maintenance of dependency on the data, right? All these kind of required fields are getting values or not. All this kind of data validation will be applied by this set of people. Maybe the encryption access control will be done by this people itself. Actually, we can put it in the top. The I mean, like whoever is helping us setting the platform, right? They itself will do this activity. Helping us in setting up the security measures also in the cloud platform. Then API integration or security setup again, connecting with the external APIs, setting up of the IAM and access controls, key management service, implementation of encryption of storing the data, security layer setup, API connection setup, getting the API connectivity or getting the service account keys, IAM integration, including the service account handshake, SA key generation. All this will be done by the platform team working with the governance team, data governance team. Using some tool like compliance manager and all, we are going to have the sensitive data, GDPR data, HIPAA data, or GSAM data, or CPNI data, customer premise network information data, right? Such kind of sensitive data, compliance measures, working with the compliance team to get the acceptance for making use of those data and all we had to get, because we are using customer data. Backup and recovery, right? How to how much frequent the data has to be backed up in the raw layer, how the data can be kept in the disaster recovery layer, how the cloud is accepting, how much the availability of data the cloud is providing to me. All this kind of setup and all has to be established by our platform team or administration team, right? Testing and validation of literal ongoing testing, the development testing. This is the data quality testing. The testing of the literal processes and all what you are doing has to be managed and the goal while making to the production how the DevOps is going to help us, DevOps team. Usage of CI/CD pipeline, setting up of CI/CD environment, right? Using CI/CD. Then continuous monitoring, alerting, working with the production support team, production support, all this setup, who is going to do what, right? Hope this gives you a complete idea of who are all going to involve and what all the activities are going to happen to entirely execute this project, which includes the personas who is going to involve in managing this entire project, especially at the very higher level. The business requirement will be brought by the business team and the client, who will be working, the business architect will be closely working with them and hand over that to the enablement team. Enablement team and the business architect will bring that to the consultant or the onshore management team or whoever. From there, the work will be distributed to the offshore and the work will be done by even the people kept in the onshore also. The development team may be kept in the onshore also. Data engineers can kept in the onshore also. Right? So there, the work will be started happening. So the work will be propagated via the solution architect, via the leads, via the data solution architect, who will be connecting with the enablement team, the business team and all, business architect and all, to understand what type of data, what are the attributes and everything, transform to the data engineer, and the work will be extracted back and forth and delivered. So this is what, as a team structure, we can expand this team structure based on who are all going to involve. Maybe the other team members will be coming into picture here. Somebody like, I'm just keeping it blank because the testers or CI/CD people or maybe like platform team or maybe like support team, production support team. Everybody may be coming into picture as the rest of the personas who is going to involve in making this project successful. Hope you are all good guys, what I'm speaking, right? These are all the involvement of the different strategies or different steps and all in executing our entire project finally. And we provide, yes, I'll share this. And ultimately, I'll be sharing this presentation to all of you, including the steps and all what you're going to execute. Maybe I kept the code somewhere embedded into our into our project itself, but the embedding of code is not exactly working as I expected. So I will share you the code also in the then and there level. Okay, wait for a while. Okay, I'll share it. Don't worry. Okay, so the Gantt view, the Gantt chart view, the milestone chart of how we are going to achieve this project outcome. So the major activity will be involving in creating the data pipeline and ultimately producing the output in the reporting layer, in the consumption layer. So creation of the unified data lake or a lake house or a big lake environment. We are going to start build the data lake and the lake house first. Then we are going to perform setting up of the environment, setting up of the platform, then ingesting the data, creating the streaming data, the data science consumption layer creation, unified data lake creation, lake house creation, providing the data for the consumption purpose, and ensuring all are developed and going live. This can be done in an iterative basis also. All these phases can be executed in parallel in a MVP model also. This model is a kind of a waterfall model. We can use other models like MVP based approach also to say Let this be achieved in quarter by quarter. Every activities we do quarterly with some minimal component. Yes, the entire life cycle is showing us, the STLC is showing here, right? Okay. These are all some of the nitty-gritty things. These are all some of the initial things what you are supposed to consider in this project. Irfan, in day 10 and 11 class video is not shared. Yes, I'll share that also. I missed to do that. I'll share every of this sessions video, guys, including this project. Make use of it. Okay, fine. So reference architecture, the entire architecture, the holistic architecture of what are the tools and technologies, what are all the personas or consumers going to make use of it, what are all the allied services we can use in a project is listed out over here. So the data ingestion we are going to do, the streaming data ingestion, the real-time flow and the batch flow we are going to have. So this is a reference architecture for Lambda. We have a Lambda architecture designed here. That means we have both layers. That is speed layer and the batch layer. So this project is going to help us bring the data in a speed layer also. The speed layer I'm yet to show you guys. Maybe I don't think we can cover that by today. But the batch layer first we are going to deal. We are going to get unstructured data, literally image data. We are going to get complex JSON data, semi-structured data. We are going to get relational data. We are going to get API data. All these are our potential data sources, right? We are going to ingest the data by using different tech stacks, including Dataflow, Dataproc, Bigquery, and Dataprep also. But mainly you can concentrate on any few of these components, not all of them, primarily. All these points, whatever I have listed, you can go and compare and you can go and understand what we are doing, identifying the data source to ensure the data ingestion tool can connect with all type of data sources. We have to identify the data sources and whether we have enough ingestion tools available to ingest the data from all these sources. Secondarily, read the data from the source by using these tools for batch processing or real-time processing and bring it to our platform. For batch data, you use this kind of components to bring the data to our multi-tenant data ingestion layer called GCS, the lake house or data lake we are bringing the data into. Bring the data into the data lake. That is the step number 3 what we are doing. Then step number 4, from the raw to the curated, you move the data by cleaning, cleansing and doing all the operations, right? Handle via Dataproc or Bigquery by storing the password and other information and all using the Azure or the GCP key, GCP KMS store, key management service store, for securing our sensitive data. So store the username and password and all somewhere in that way. From the curated to the analytical layer, the data is going to be stored into the analytical layer of our Bigquery and all. We perform some sort of data aggregation and store it across, enrichment and all and store it across, where we go and use the concept like big lake and lakehouse architecture. We go and keep the data first in the data lake of GCS. Then we go and create a reference from the GCS storage to our Bigquery by creating big lakes. What is big lake? We are going to talk. So you can see here, we are going to have a big lake architecture used here. So I'm going to bring the data to our storage layer and I'm going to directly connect from that storage layer by creating an external table by using our Bigquery, or even I'm going to use some Vertex AI connectors and all, which Google have provided for me to go and use the model directly from the external connectors. Like big lake architecture, we are going to implement heavily here. What is big lake architecture? We'll be understanding. We know about it, but let's try to recall it. Okay. So we are going to connect and pull the data between the data sources like the cloud storage by creating an external connection or by loading the data into the table also. Anything we can do that, we are going to do it in our architecture, the entire flow of our program. Right, the big lake and the lake house, both architecture we are going to use. Big lake is more of referring the data from the external, or simply say big lake means it's an external BigQuery table. Lakehouse means, yeah, internal or a managed BigQuery table or a native BigQuery table where the data is stored in the underlying Colossus layer. We are going to apply this architecture in this entire of our project. Different places I implemented that. Data serving will be done through BigQuery. And the data will be sent to even Cloud SQL also for egress, for the consumption layer. But I'm not going to reach till the consumption layer. Step number 6 is all about taking the data to the consumption layer, to the BigQuery and the Cloud SQL. The people will be using either BigQuery or some Cloud SQL or Cloud Spanner environment. Serving layer. Processing will be done by mostly Hadoop and Spark and BigQuery. We'll be having the data flow also included here, but in the speed layer. This is the batch layer we are first of all targeting towards. Once the analytical and the egress layer is reached, we need to design the data agnostic data lakehouse environment or a data warehouse environment using BigQuery for allowing our consumers to make use of building AIML models or data analytics operation or the reporting operation to be performed. That is over here. We are dedicatedly giving a unified lakehouse and a big lake environment for our consumer to make use, or lakehouse and a data warehouse environment for our different personas to consume the data from. And from the BigQuery data warehouse, the data will be collected by the visualization tools like Looker or anybody. That is the 8th point. Altogether about it. The 9th point is all about we are not going to only use the core components. These are all the core components we are aware of. GCS, BigQuery, dataflow, dataprep, dataproc, Cloud SQL, Looker, all this, including the IAMs, Identity and Access Management, Access Control List, multi-factor authentication. Like these are all some security layer. But mainly, some of the allied components, data discovery we are going to do using Dataplex. The logging and monitoring and all we'll do using Cloud Logger. Cost management, we are going to manage the cost of using our, the cloud custodian will use the cost analyzer, the cost manager. The complaints will be managed in the trust center, complaints team, the data governance team. The platform team and the infrastructure team will use backup and the disaster recovery service of GCP. GCP best practice center is available for following some best practices. These are all some supportive components that will be helping us, including the key management service by using cloud key management or the cloud KMS service, key management service. We call it as KMS altogether. KMS service, key management service. We use for data quality, even Dataplex. GitLab for the repository of code management, Git repository. Scalable databases we can use to egress the data to store some of the metadata and all. All these are the 9th item, which is the allied components. Implementation of the supportive services. Required supportive services, whatever is needed. It's not only about dealing with the core components. Supportive services are also there. We can make use. Third-party data consumption and enablement of security and all done by the IAM and the access controls, what is defined over here. I'm going to enable IAMs and the access controls for the consumers who are all coming from the artificial intelligence, machine learning team or data analytics team, egress team, reporting team, third-party vendors. I'm going to open up for them and all the security layer, which will be done by the administrators, right? By our platform engineers, platform management team, right? The external systems will also be connected. Maybe I can put like this. External systems will be connecting, or our stakeholders will be connecting to our platform and collect the data, especially with our unified data warehouse, they will connect. So I can put it here, in fact, more obvious to put. They'll be connecting to our data lakehouse or into our big lake or into our data warehouse, unified data warehouse. They'll be connecting. Let me mention as data warehouse. So this is the holistic architecture. Hope you are able to understand this, right? Overall, the architecture, how we are supposed to design. We call it as a reference architecture. We are following a Lambda architecture model here, right? It's an enterprise cloud modernized data layer or data architecture where we have sources, ingestion, processing, serving, data insight layer, or the data lake layer, and the data warehouse layer or a lakehouse layer. This is a data lake layer, which is not clearly mentioned here, right? Let's put here. The data lake layer, we have data lake layer, we have, and the data lakehouse or a data warehouse layer, we have. The unified data warehouse layer, we have. And then the other services. Other services we have, or other service layer we have. These are all the overall layers of what we have in our this particular project. The overall architecture of this particular project. With me in this thing, right? I just wanted to follow a entirely a different approach, different model to show you this project. It took very longer time, but however, this is the whole architecture, holistic architecture. Now we'll go only to the ingestion layer. We are going to only touch base on the ingestion layer and the processing layer for now, and serving layer maybe you can consider, and some sort of data lake layer. This layer and all we are going to touch base. I'm not going into the orchestration in the scheduling layer, which includes the cloud functions I did not mention here. Maybe I can mention the cloud function also in addition to that here, but however, I did not mention that here, it seems. Cloud functions. We are supposed to have cloud functions also included here in our current architecture. Okay, the tool wise I'm talking about. Okay. Maybe I'll add that point also. I'm missing that here. So I'll add the 12th item as the orchestration and scheduling using orchestration scheduling layer using Airflow and cloud function. Done this. Okay. Now let's enter into our ingestion layer. Then we do ingestion cum curation also. Ingestion cum curation also we'll be doing. So first we'll go and talk about the ingestion layer at the very high level. At the very high level. So we are going to get the data from different sources. Okay. And it contains multiple types of data, but multiple type of variety of data and multiple sort of data. Like we are going to get from different source systems, such as, why this is coming in the top. Let it be. Such as the exchanges and currency data. So basically, every day or every once in 6 hours or 8 hours, the currency values will be set. How much I can get the Indian rupees equivalent to US dollar. That currency information, the exchange information will be set in every part of the world, equaling relating with the euros or USDs or everything, right? That currency data is going to be exposed by some forex activities and all we can do with that, correct? So that is exposed by some APIs. So we are going to have an API hook done over here. So we are going to perform an API calls using the web service APIs exposed by some external system. We are going to use the ingestion layer with the API calls performed. And it is going to do something in the background of our platform as a part of data processing or data analytical operation that we are going to perform. But the ingestion we are going to do with the help of API calls using Spark or somebody. Let us not worry. And what type of data we are going to get? The complex nested JSON data we are going to get. Then the payments made by the customer, the transaction made by the customer, other transaction made by the customer, and the accounts information will be collected or will be stored in a point of sale system into the databases, into the Cloud SQL, into the Cloud Spanner kind of databases. My external systems are storing, or any other databases they can store as well. We are going to collect that data too by using different techniques like change data capture technique, complete data ingestion technique, slowly changing dimension 1 and 2 technique, and all we are going to follow. Maybe I'll open up this also for your easy understanding. Then the data of loans will be collected in the file system, in the storage containers, in the Google Cloud Storage layer. We are going to get this data ingested into our data lake, such as loan data, customer data, and the credit card images. The last one represents what? The credit card images. We are going to get it into our GCS storage, into our data lake. We are going to take that data and all by using different tools and techniques such as Dataproc we are going to use, Bigquery we are going to use. We are going to create a Bigquery big lake tables, and we are going to bring the data into our platform. Even we'll be using subsequently for the speed layer and all dataflow, pubsub dataflow and all we'll use. That is a speed layer. This is for only the batch right now we are talking about. So this is a complete data ingestion cum curation activity. How we do is the diagram mentioned here, which includes cloud function for event-based data ingestion, event-based triggering of the jobs, and the orchestration once in an hour, once in a day, and all we are going to do with the cloud composer, which is nothing but Airflow scheduling. So in our current architecture, we are using mainly the Dataproc, Bigquery, cloud storage. The cloud functions, cloud composer, and sources as cloud SQL, cloud spanner, data lakehouse as or data warehouse as the Bigquery, and visualization we are going to yet to build. And we will do some data discovery and data quality analysis and all by using the Dataplex kind of tool subsequently. But for now, we are doing the ingestion with the help of this minimized tool, not going with multiple tools, because there is a big challenge we have on getting all the tools enabled. Costing will be incurred more. So the company will open up some of the tool and say, with this tool you try to enable, and you ask for these tools, we enable it. We call it as a directional tool. Company will, the directional tool means it is the direction across the enterprise we are going to use. Not every tools are going to be opened up for everybody's usage, for cost control and all. We call something as a directional tool. Mostly we'll be preferring cloud native solution to provide. But at times we can't able to always get cloud native solution. For example, I wanted to ingest the data from a REST API. I can't use cloud native solution. I have to go with some non-cloud native solution, which is nothing but Dataproc. The Bigquery is a cloud native solution. Dataproc is not a cloud native solution, but still I can't omit Dataproc. We are going to move towards that. Then we are having this as a complete data curation pipeline. This is the lower level view of the curation pipeline. Data processing, serverless data ingestion, big lake reference architecture we are creating. The data from the cloud storage will be referenced by using big lake. Then we do change data capture load or full load, slowly change dimension 1 and 2 load by creating stored procedures from our lakehouse To our lakehouse, we build the data. Then finally it will be visualized. This is one more lower view of this particular data curation layer. This is the lower view of the curation layer. So we don't want to worry too much on this high level layers of what we are going to use on that. We are going to see each and every of this pipeline, how we are going to design and execute. This is the work done by whom? Data ingestion developers. We are going to first play a role of a data ingestion developer, and slowly we are going to move towards the data curation developer. Then slowly we are going to move into the data analytics. And we are going to see the data engineer who plays a role of the, like data science model application also for the ingestion. We are going to use the data science pre-built model available that can be used with the help of the GenAI methodologies and all, LLM methodologies and all, to perform some sort of intelligent data ingestion. You just see finally what you are going to do on the credit card images. Okay, guys, keep it aside. We'll go into that. Okay, now the very first ingestion we are going to see here is from the customer data, the customer dimension data we are going to collect, or we are going to get it loaded on a regular basis, on a daily basis, hourly basis, or whatever, into our GCS storage, which is a dimension data. And the loan data is also going to be loaded into the GCS storage. What are the GCS data we are going to get is customer data from the banking system, from the front office of the bank, or from the web GUIs, from the web system, we are going to get the customer data, which contains the profile information, customer profile information. So address data, branch, where the customer is having the branch, home branch, customer ID, date of birth, email, first name, last name, and all this information. We are going to get this data in a JSON format from the source, from the web GUIs, or from the source system. They are going to directly ingest the data into the cloud storage. And we are going to, once the data is available in the cloud storage bucket, our cloud function is going to trigger the Bigquery SP, or already we have a maybe like a lakehouse built on top of it, a big lake built on top of it as an external table. Or the stored procedure is going to do what? It's going to create a reference on top of the data. One second. Create a reference on top of this data, the stored procedure that we have developed in the Bigquery will be creating a reference on top of this data stored in the GCS bucket by having this reference dotted lines created. So we can query the data from the GCS storage via the Bigquery. Then we are going to apply the slowly changing dimension 1, where we are not going to maintain the history. Very directly, we are going to use the simple merge statement to load the data into our customer raw table in our data lakehouse, into our data warehouse. This is the one flow what we are going to execute right now. First flow. Pipeline number 1, ingestion number 1. Ingestion number 2 is all about what we are going to do. We are going to get the loans data. Customer have got loans for different products, car loan, home loan, travel loan, health loan, or any loans they are getting. That data we are going to get on a cloud storage bucket even. We are going to have some cloud function trigger this stored procedure, where we are going to have the same concept of the big lake architecture use. Big lake means what? We are going to create an external table on top of the cloud storage. And using that external table created on top of this cloud storage, we are going to perform slowly changing dimension number 2, where we don't update the data in the target. We always insert the data into the target. But we update is the data, the older data, whether it is in a current state or not. No. Is current, I'm going to set as false. And valid to how much? Valid till today. After that, it is expired. We got the data next with the next version going forward. So we are going to have some sort of update made on the older data to outdate it, to make it not current, to say you are not a current data going forward. I got the current data, the most recent data from the source. So if there is any changes made on the loans customer have got, I'm going to outdate that, right? So that is, we are going to do it in the loan data as a ingestion number 2, where we are going to implement slowly changing dimension number 2 implementation we are going to do. SCD2 we are going to implement. These two activities let's first do. Let's first bring the accounts data and the loans data, so customer data and the loans data into our Bigquery lakehouse. Okay, via or by using big lake concept. The automation of running this SPs to automatically generate the data, we'll finally see. We'll finally go and execute in an automated fashion by running our cloud functions or whatever the functions and all we have developed. Okay, so let's first try to understand how this data is getting ingested. So we are going to do two types of load. One is the historical load. I'm going to take the day one data, the first day data, first time data, day one or first time data, and I'm going to load that into my final table. And I'm going to take from the second day onwards, I'm going to get some additional data. Some existing customer got modified or new customer got added. Those data I'm going to load it into my Bigquery table. So let's try to go through the test P of what we are going to do. So we are going to create some environment for that first of all. I'm going to have some data sets created like Inceptez bank raw data set, Inceptez core banking data set, Inceptez core banking analytics data set under the project called Unified Financial Data Lake project. Maybe I have two projects used overall here. One is this Unified Financial Data Lake project, and another one is something what we have here called the Civil Dolphin project. So this is the project, what I am using for creating the entire project code and everything. But I don't want to use this environment because already some code and some project is executed here. Let's not use this. Let's use a different project for playing it around. Okay, so I'm going to entirely use this particular project called Civil Dolphin project to go and create all this. Let me find and replace this here. I just made some replacement of the project information where I'm going to create the data set from scratch. Like core banking is the raw data set. Analytics is the analytical data set, the final gold layer, right? And this is the silver layer. Curated is the silver layer. This is the bronze layer. Like this, I'm creating all the layers for my purpose of usage. So let's go to the Bigquery. And we can do this implementation of creating this data set and everything by using some tool like Terraform or whatever. I'll finally show you the Terraform. I even missed that to show last time also. So let us use a clean UI for doing that. I think already we have a couple of this kind of data sets and all even available here also. It seems core banking analytics, core banking curated, core banking. We don't have this Inceptez bank raw, right? Let me not create it. We'll create it later. So this data sets I'm going to create. Right, core banking data set and all this. Maybe what we'll do, we'll go and create it as one, because if you wanted to get some data from there and all, we can get it. Okay, let me not try to remove this. Okay, let me just have it retained. I'm creating it as one everywhere. Core banking, one and all, I'm just creating everywhere. So let's go and create this data set freshly. We got this 3 data sets created. Okay, 1, 1, 1, like this I'm creating. Now Under this banking data set, under the civil Dolphin project, I'm going to create the stored procedure. Maybe like we can use this stored procedure, or I have the stored procedure code embedded in my base. Let's use this code. Then let's use this code base. This is the cloud function of performing the call of that stored procedure that we'll use later. But for now, first use our stored procedure. Where is the stored procedure? This is the one. Slowly changing dimension number 1, I'm going to use to load the data into the stored procedure. So create schema if not exist, right? Create external table. Okay, let's create this external table and create the stored procedure on top of it. I created all the data set. Let me replace this with this data set name. In the raw layer, I'm creating. In the raw layer, I'm going to create a table called customer staging. This table is nothing but a lakehouse table I'm going to create. So, sorry, it's not a lakehouse table, it's a big lake table I'm going to create. So, for what reason I'm going to create like that? If you see here, we're getting customer data, right? I'm creating a big lake table to say what? Hey, create a table in our maybe like the Bigquery environment to go and refer the data that is stored in the cloud storage. Don't load the data into this table. Keep the data in the cloud storage itself, in the raw layer itself. Let's go and refer the data by using the cloud storage. I mean, by using the Bigquery. That is what we are doing here altogether. So we are telling the data in the cloud storage bucket is of JSON format. So I'm going to bring the data from the cloud storage bucket location where it is residing. It is residing in Inceptez common bucket. So others can access this data. That's the reason. Under the data set, I'm going to bring this data. So let me go and create one table on top of it. So I'm going to keep the data of the day one, first of all. I'm going to refer the day one data, first of all, not this data. So where is the day one data reference we are doing here? So you can see here, this is what. I'm going to create an external table on the day one data set. So drop if already the table exists, and I'm recreating a table over here for holding the day one data. Then I'm going to load the data into or refer this data from the staging layer, which we did not create yet. Let me go and put this data set in the project name. Project name is different, right? Here I'm going to first create a table. So this table contains the reference created for the file what we have or where we have the data. We have this JSON data parsed and accessed, phone number and all the information. In this data set, we got access now. The banking one data set, we got access altogether. Okay, this is the data set what you're accessing. Now, this is not actually loaded into the table, it is just referencing, creating an external table, what we did as like how we do in Hive and all, we are doing this activity. Now, this data contains what in it? Like this is the data I already have placed in our cloud storage in this URL. The new bank data set or somewhere. I kept this data already in the cloud storage in this Inceptez banking project folder. Maybe we'll do one thing. Rather than keeping it here, we'll keep it in our cloud storage bucket of this one. So it is easy for us to go and access and see like what data we placed. In this data set, I'm going to place this data. What data? This one. Low customer day one JSON. So I'm getting almost how much? How many number of customers? 30,000 customers in this JSON data on the day one. Let's assume first day 30,000 customer have registered in my business. Or this is my historical data. Historical load we are currently doing here. So I'm going to keep this historical data in our GCS storage. GCS storage bucket. This historical data I'm keeping. Let me go and access this historical data from here and load it into my table. Removing this table. Again, I'm loading from this location where we just placed the data. Okay, now we got the data loaded into the core banking one data set under the table called custom staging, which is referencing the data from the external storage, cloud storage location. We got the first day data loaded. Now what we are going to do, we are going to create the SP. What are the SP we have over here? Something called raw, BQ raw or whatever the SP that we are having over here. We are going to create this SP. So I'm going to replace this SP data set and everything into this one. Civil Donfin under the core banking itself. Let me create this particular SP. So under the core banking, I'm going to create this SP. What it is going to do, it is going to take the data from the core banking table what we just created under the Civil Dolphin project. It is going to take the data from that table, or it is going to create one more table called customer raw. The customer raw is going to be merged with the data referencing from the big lake table that we created. This is a lakehouse table, this is a big lake table. We got a big lake table created and loaded some data, right? Into that big lake table, this table is going to be merged with. So let's go and create this SP to simply perform an activity of creating a table if not exist. First time alone, it will create this customer raw table, which is not available for us. The core banking one raw lake, raw data set, we don't have any table called customer raw table available already. So we are going to get that created as a part of this SP execution. Once it is created, the data from the customer staging, in fact, the data is present in the GCS bucket will be referenced by the customer staging and loaded into the Bigquery customer raw table by performing what operation? Merge operation. I'm going to tell what? Hey, merge into this raw table from the staging table, taking the data from. When matched with the customer ID, then you do update. If not matched, then insert the new data into the table along with the current timestamp added in the table as one of the column called something like courteous or whatever, like last update or whatever. Like this, I'm creating an SP like this in our BigQuery environment to simply perform a merge operation. I'm creating this SP. This SP got created here as a routine, separately it got created. Close this particular SP terminal. I'm going to call the SP now. Before I call the SP, I don't have any data in my raw table. I don't have any data in my raw table currently. Okay, I had to execute the SP, then only the raw table data can be verified, right? So I did not execute the SP yet. So this table is not yet created, or I'll just create it manually, or it is not yet created. After it will be getting created and it will be loaded with the data from the staging to the raw table. Raw table altogether. So let's run this SP to get that done. Now we got the data added into the raw table. With the help of the staging table, the data has been brought from the 30,000 records has been brought from the JSON file and loaded into the table. So what is the count we have on this raw table now? We got almost 30,000 records count very directly. Now we are going to execute the same exercise for the next day data, the subsequent day data. This is going to be automated with the help of our cloud functions or cloud composer or somebody. But for now, I'm going to do a subsequent day execution. And I'm going to see what happened to this customer IDs and all after I executed subsequently. So we are going to have this table. All you have to do is what? Change this project ID and the dataset name. Rest will be assured for us, right? Whatever the dataset you want to create or maintain the same dataset name, that is okay. All you have to change is only this dataset name and the project ID, wherever it is applicable in your environment, right? So I'm creating one more staging table. The same staging table I'm replacing on the next day run. Okay, we'll talk about it, Hashwant. Okay, we are going to execute, or we are going to create one more, or what is the difference between Big Lake and Lakehouse? Big Lake and Bigquery table is, Big Lake is like Hive external table. Lakehouse is like, our Bigquery table is like a Hive managed table. You consider like that. So here what I did is I told, hey, go and create an external table to refer this data. When I drop this table, the data will still there, available there. But here what I'm doing, I'm loading the data from the external table to the managed table. The managed table is Lakehouse, external table is Big Lake. With me? This is a Big Lake table because it is referencing the data. This is a Lakehouse table which holds the data. Finding the difference? External table is Big Lake, managed table is Lakehouse. Consider that way. Okay, fine. So we are again reloading or recreating a table for the next day run. Yesterday run is completed. So yesterday run, when you go and see the data in the table, we are finding in this table, if you are going to see the data, we are finding for these customers what all the data is available. Let's take this and store it somewhere or keep it somewhere for our reference. Let's run this query before we run the second day run. There is some data is available for this customer, right? When I go and do the second day run on the second day data, what I did is I taken the data from the file system. I taken some data for sample data of another 20,000 and odd records. In that 20,000 records are new records. Only the last 6 records are the existing records who got modified. So let me open this file once again. We got these 2 files, right? We got these 2 files. From the first file, I have taken almost 6 records. This customer ID data. Let's take this customer ID data. Okay. Some customer IDs are not there, let it be. So some new customers are there. These 20,000 customers are new customers. Some additional customers we are having, the existing customer itself got modified. For example, if you take this data, 404571, this record, let's consider, right? If you take this data and compare with the day 2 data, the same person has been modified with what? With the phone number maybe. This was his existing phone number. This is his new phone number. Some new phone numbers and all got modified. The existing phone number got modified to new. This is a change that got occurred in the customer side. The data what we have received on the second day. So second day data onwards, we are getting the newly added customers and the modified customer information. The concept of incremental data ingestion will always give us some existing data updated information or the newly added customer information. So I'm going to load 20,006 records, where the 6 records are, the 5 records, whatever the customer ID I mentioned here, are all undergone with some modification in the today's data what I received. And we got 20,000 more customers got added. So we got earlier 30,000 customers. Now we got 20,006 customers. What is going to happen in the target table? Newly added 20,000 customer will be inserted. Additional 6 customers who are already are available here will be updated. So Inceptez update is going to happen with the help of the merge statement that we wrote. So you can find the second day data we are loading into the staging table. Then we are calling the SP to load the data, to update the data into the target table. Now what happened from the staging, from the lakehouse table, from the big lake table, the data is loading into the lakehouse table. This is the big lake table referencing the data. External table. This is a managed table, which is going to get the data loaded literally. Now we can find the comparison between these two data sets, especially the phone number. If you go and compare for 4570 customer ID, who had a phone number of earlier 1485, but whereas now 1100 is a phone number got modified. For Christiana Taylor, 7033 is the yesterday's phone number. Today he got modified into 1111. 314-1111 phone number got modified accordingly. So we got the data merged into the target table without maintaining the history. Yesterday, what was this customer phone number? If I ask, you will say, I don't know, because it got updated today. Whatever the data that we newly got for Christiana Taylor, this phone number got updated with the today's phone number what he is holding. If you ask me the Christiana Taylor's yesterday phone number, I don't have it maintained. This one I taken as I ran the query before update happened. Now it got updated. I could not able to see the Christiana Taylor's old phone number. That is nothing but slowly changing dimension number 1, which represents history will not be maintained. The existing history will be deleted, will be updated. That is where we are doing the merge operation with the update operation performed on the SP number 1, which you are familiar with. You are all aware of this concept even earlier also, right? So we are implementing, but the SCD type 2 we are going to implement somewhere specially. We are not going to implement in the way how we have seen earlier. We are going to use some other methodology to implement the SCD type 2. So this is the SP just we ran. The SP number 1 we ran to perform the merge operation. Update else insert. So 5 records got updated, 20,000 record got inserted. So totally how many records we'll have now in the overall table? Earlier 30,000, now 20,000 got inserted, overall 50,000. And 6 records or 5 records got updated. So we'll have 51 or 50,000 records, 51,000 records we have. 30,000 plus 20,000 and 1. 5 records got updated totally because of the customer ID matching. I'm telling what, if the data that I received from the source, the staging table, matches with the target table, then go and update the data like this I'm telling. So the data got updated. Okay, almost 51,000 records we got. Now, this is one iteration, SCD type 1 iteration. So we completed this part. We completed this part. Are you all with me in this? Day 1 we ran, day 2 we ran. We completed this part. The data got updated in the target. Maybe I have given you the query for your reference to here. You can see I'm just taking this customer and seeing the result. Yes, it's showing me as per my expectation. Okay, this is pretty direct use case, right? We got, but this implementation made right now. The only thing which we did not see on this pipeline is how we are going to trigger this with the help of the cloud function. That I am not showing interest right now. First, we'll see how the strategies and all we are implementing in bringing this data. We don't have enough time to see that part. That part we separately see. We'll go and automate this part and see, okay, this is how the cloud function implementation we can do. Okay. But however, I have the code and all available for doing this cloud function activity of calling the SP number 1 or SP number 2. Whenever a new file come into our cloud storage bucket, whenever somebody push some data into the cloud storage, my cloud function will be keep looking for. If any data that comes in, immediately it will trigger the SP and get the SP executed and completed. We don't have to do this work of manually running this SP. That is the core part of our understanding. Okay, just in a controlled way, we ran this for a better understanding of how it works. We can automate it and have it run on a daily basis without having our hassle. Without we put any effort, effortlessly, the automation can be made. Trigger the SP whenever a feed is received in the cloud storage. That automation we'll see in the subsequent one more week of discussion that we are going to do on this project. Let's conclude this. The first ingestion is completed. The second ingestion, let's move into. The second ingestion, what we are going to do? We are going to follow the cloud function based GCS to BQ data ingestion using SCD type 2. We have did SCD type 1 earlier. Cloud function based ingestion. Okay, we are going to do. What we are going to achieve here is the loan data we are going to get. How much loan the customers have taken recently. How much amount, what is the collateral they have given for the loan. What is the customer ID, when the loan is ending, what is the interest rate, loan ID, payment frequency, start date of the loan, status of the loan, currently it is in active or closed state. All we are going to receive from the source data. In a JSON format again. Simple JSON format we are going to receive. We are going to get this referenced, that's where I put the dotted lines here. Referenced by creating a big lake table. Then we are going to load the data into the final lakehouse table by performing SCD type 2 load, where we are going to do only an insert operation. Even update operation we do, but not on the data. We'll be updating some flags and some older values, older data sets, information directly to deactivate the older data. We maintain the older data. We don't overwrite the older data. We deactivate the older data and we create a new entry of the same data. So we will see the data looks like duplicate, but it is not duplicate. Same customer got his loan maybe like percentage. The loan interest percentage got increased or decreased. Right? I'm going to maintain the old loan interest percentage is how much, and until when the customer have the old interest percentage, until when the new interest rate is starting for this customer, I maintain both records. Why? If I generate some report prior to the update that I made, prior to the new loan amount, then the calculation will be differing. So I'll be doing a time travel data validation or data reconciliation or data analytics in a time travel fashion if I want to do. Let's assume the customer have taken a loan of 1 lakh rupees. Let's assume he taken it last month. Last month his interest percentage is 10%. So I might be charging him how much amount? 10,000 rupees? No, 1,000 rupees. Right? 1 lakh rupees you have taken. I'm going to charge him maybe 1% charge. Let's assume. So he'll be paying. Principal you leave. The interest of 1,000 rupees he'll be paying. Now the loan, now the interest is increased to 2%. This month onwards, the interest is increasing to 2%. Now from this month onwards, I'll be collecting 2,000 rupees from the customer. I'm going to do an analytics. How much amount I collected so far from the customer for the loan he have taken of 1 lakh rupees. Interest alone, how much I got. If I calculate now in a bank, how much I'll be seeing? 3,000 rupees I collected so far in the past 2 months. How do I validate it? How do I say, hey, 3,000 is not a right figure? The customer is supposed to pay 2% of interest, but he's paying only 1% sometime and 2% another time. How the 3,000 came? I could not able to understand that, right? How can I able to understand? By joining with the timestamp also, saying like, hey, until this date, he have paid only 1% interest. From last month only, he got 2% interest. So whatever he paid earlier month is 1,000. It is supposed to be 1,000 only. So I will do analytics or I will do the profit ratio analysis, everything based on the historical data. I'll do a time travel and do the comparison. Agree or not, what I'm speaking. So what is the importance of maintaining the historical information? SCD type 2, the importance you are able to realize. Time travel I can do with the help of historical or with the help of slowly changing dimension. 2, if I still maintain what? If I still maintain the history, if I still maintain the timestamp of when it occurred. When it occurred, I'm going to generate. So the earlier we have seen the version, but with the version we could not able to understand from when onwards the loan percentage got changed. I can't able to identify. But by maintaining the timestamp from when it got deactivated, when it got activated later, I'll be having a very good method of identifying the result as per my expectation. So let's go with that second SP. Where is that loan SP? This is SP number 2, where I'm going to process the loan data. Okay. SP for SCD type 2, loan data processing. Okay. This SP I'm going to create to manage the loan data. So let me make the data set and the project changed accordingly. Okay. So first I'm creating a loan raw table which contains all these columns which we are going to receive from the source. But in addition to that, I'm going to maintain some more columns called is current. Whether this is the current data or the old data. By putting the filter, I can know what is the most recent data of the customer, of the loans. It is valid from which date and valid to which date. The valid from will contain, if it is current, then the valid from will be containing from the date when this data is loaded into this table. And the valid to will be blank because it is in a current state. It is valid even now also. But if, let's assume one customer have taken a loan and the loan percentage got changed. The interest rate got changed. Now I'm going to set the valid to until yesterday. From today onwards, he is getting a new interest percentage. So I'll set the valid to as yesterday's date. And this current I'll set as false for the same customer with setting the yesterday's date as a column here value, the column value here. And I'll insert a new entry for the same customer by mentioning, hey, this customer going forward is going to have the new loan rate, the new interest rate. So I'm deactivating some data by setting the valid to as current date of when I'm deactivating until when the customer is maintaining this loan value. And I'm going to make the is current also false. So anybody put a filter of is current equal to true, I'll be getting the output of those data alone as a recent data. Rest of all data will be shown as a old data. Is current false if I put, I'll see the older version of the interest percentage or whatever the customer had. The lower version of the same customer I can see. That is what we are going to implement here. But how we are going to implement that trickily here? So if it is a new customer, I don't bother. I'll be just always inserting the entire information of the new customer, including I will first make the column called is current as true, because a new customer when he is coming to our system, I'll make the is current as true for the first time. Every customer who I'm inserting for the day one will be having the is current as true. And the current timestamp of from when he started his journey in our bank. But the valid too, I make it as null because I don't know how long this loan percentage or this loan is going to be valid for, because this is the first time I'm getting the data. I'm not going to deactivate this. Like this, I will insert the data for the first time like this into the loan staging table. Or from the loan staging table, I insert into the loans raw table by merging it using the insert statement. I'll insert the data. Right? I'll be inserting the data into the table of new customers. Insert all the new records. But if it is an existing customer, already the customer who taken the loan is again coming today with the modified interest rate. Something is changed in the new customer data. Loan type is changed, payment frequency is changed, interest rate is changed, amount, end date, collateral or status is changed. Something is changed. On the yesterday's customer who is in an active state, something got changed. What I'm going to say, I'm going to make him as the older data as inactive. The same customer data, if I receive today once again, I'll make the older customer data inactive. The prior version of the customer inactive. And valid to I'll set till current timestamp. Then I'll insert the data into the table with a new record. As a new record, I'll insert. So the old record got expired, old record got set into is correct false, expired. And until how long he was in that old value, I'll set the timestamp also. So I'll insert the same customer once again in the same table with the new value of whatever got changed. Maybe amount got changed, payment frequency got changed, interest rate got changed, something got changed. Very simple logic we are writing here. So let's go and see the data. I'll get a clarity. So I'm going to create this particular SP also for our reference. To implement SCD1 also I can implement, but we'll implement this as an example. They are getting the SP created. We are going to load the data. By following some logic what I mentioned here. Loan staging, I'm dropping if already exists. I'm creating an external table, which is nothing but a big lake table to load the day one loan data. Just for showing you guys how it works. So the big data table data I have day one loans. How many customers have taken the loans on day one? There are around 9,950 customers have taken the loan on day one. Okay, on the day two, there are around a couple of customers taken the loan on day two, out of which some of the customer, the last few customers, got their loan value changed, got some value updated in the source. Let's take this customer ID. This customer ID have an interest rate of 4.73% earlier. Now he got the same interest rate, that is fine. But the payment frequency, he got modified to quarterly. Earlier he had, or even quarterly it seems. Okay. Then what is the change we got made here? Let's compare this data and see. I remember making some change on this data for your reference. Let's see what is changed here. Okay, I don't find any change literally. I don't find any change literally happened here. Now what will happen? Let's assume this is the data it's going to load into the target table. On the second day, what will happen? Because of I'm checking a filter here, I'm comparing the data here, nothing will happen. I'm going to compare, hey, if any one value changed on the new data that I received today of the same customer, of the same loan ID, then you go and do what? Update. Then only you have to update. Otherwise, don't do anything. I'm telling like that. In the merge statement, I'm telling if any change happened in the any of these columns in the new data that I received from the source, maybe the source can send the same data once again also. Don't consider the data for update. Don't do any update on the data. Only if any changes in the loan type or payment frequency or anywhere, I have to find any one of the change. Let's take one more customer. One more customer. This customer has a loan rate, the interest rate of 9.01%. The interest rate got reduced for this customer. This customer was earlier have been given with the 9.01%. Now he got reduced to 8.99%. Right? Take some other customer. This customer. He is paying the loan annually. Annual payment he's making. 2055, right? 2055. Here also he's making annual payment. That is okay. Some customer, I remember I made quarterly payment changed and all. Monthly payment. You take this customer. This customer interest rate is not changed. Or maybe interest rate also changed. Okay. Interest rate is also changed for this customer 276. Day one, he was paying an interest of 13.37%. Now he's paying 11.37%. And he changed the frequency of payment as quarterly. This guy is having the payment made earlier as monthly. I mean, whether it is right or wrong, that is okay. Let's not go to that logical thinking. Just find the interest rate is also changed, the frequency also changed for this customer. So on day one, I'll be blindly loading this data into the table. Day two onwards, I'll do what? I'll go and compare if there is any change. I will not update the data. I'll insert this customer once again into the table. But by having the older data of the same customer set as not active, I'll disable the customer first record. I'll disable this interest rate mentioning until this timestamp the customer was active. After that he became disabled, and I'll activate the new record of what I received here. Going forward, this is the interest rate for him, and this is the quarterly the payment what he is supposed to make. Let's go and see the data. Right guys, let's go and see the data very quickly. We got the SP created. Let's go and run this code for the loans data. Day one, day two. So let me, or already I have placed this data, the Inceptez banking project, rather I have to use the other location. Inceptez common bucket location. Let it be used with this location. So I have to place the day one data here first of all. Okay, day one data, let's place the loans data day one. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . This is going to naturally happen. Let it be. Loans day one data. Maybe loans day two data also I'll place. That's okay. We are going to get on a next day only, but let's have it both placed in the target location, in the source location, the Inceptez common bucket one location. Let's keep it. Now let's go and run this program to create a table on top of the data, the day one data. Let's copy all this. This is the loans data load, right? Loan staging I'm creating on top of the day one data. I'm going to call the SP. So what it is going to do, it is going to load the data into the loans raw table with some records. So the SP is executing. It got for the first time loaded with the data. All the loans data of how much? 9,950 records got loaded. Right? That loans data somewhere it kept, it seems. Let it be. Okay. This much records got loaded. I'm going to see only for this customer what is the data is present on that given date. So we got this customer first time got inserted into this table. All are in a live state. All are in a is current true state until this timestamp or from this timestamp onwards. On 12:15, 1 p.m. UTC time will be maintained. It is showing the data is in a current state. It is in an active state. On a second day, I am receiving some customer information where few of this customer, 4-5 customers alone, got some changes made in their loan. So I'm going to load this data into the staging table. That means I'm referencing this data, running the SP. I don't have to run this query in a separate window for holding the older value, because however this record is going to return how much? Not 5 records, 10 records it is going to return to me. Is it returning 10 records to say what? Irfan, you know, this customer 20255 was paying a loan of 12.3 rupees to 12.3 percentage or 13.03 percentage until this date, valid 2. Now he is in a false. Now he is not in an active state. He is not in a current. The current is he is paying how much amount? How much percentage of interest? 12.03 percentage. Understood the fundamental of the slowly changing dimension number 2, guys, with the timestamp, not with the version. We have earlier seen version number 1, 2, 3 we increment. All older version than the recent version number is old data. This time we are finding a different SCD type methodology implemented here for loans data. So you can tell what this pipeline you can mention. You know, we maintain slowly changing dimension number 2 with the versioning, or not with the versioning concept, with the time and the flag concept. True or false flag we maintain for active or inactive customer information. Is active true, I'll be maintaining for the recent customer. Is active false for the old customer. And how long he is active. He's currently inactive, but how long he was active, that I'll be maintaining. Done, guys, with this use case. I hope you are good. Any question on this? The loans data we loaded into the table. We are all doing only ingestion. We have to take this data further down to make use of it for different other transformation, right? Or curation or cleansing or any sort of operation. Let's go to the third use case. This third, let's go to the third use case of we are going to ingest the data of not loan data. We are going to ingest the exchanges and currency data. Maybe we'll do one thing. You should not scold me, right? We'll go for a break for 5 minutes, okay? We'll resume back and go till 8:15, 8:30, and we'll close the session. Okay. So let's resume back at 7:35 p.m. IST, guys. Okay. Let's resume back at 7:35 p.m. IST. So the interesting part is yet to come. Okay. This is a very interesting part you are going to see. Don't miss this. Okay. Very interesting part. Okay. Fine. We'll resume back at 35. Okay, I'm back. Yeah, Kumanan, you can just ping me these questions in our in the WhatsApp also. I'll go through and get back because I don't want to talk about it right now.
Yes, sir. Sure.
Because of we have to continue this project. Okay, I'll just however answer this and bring the answers in this implementation also if possible. Okay, to make you understand. Okay.
Yes.
Yeah. One question at least I'm finding star versus snowflake schema, right? You go through the Dataverse video that I have shared very long back, right? You will get some idea on that. Okay. However, yeah, let me go ahead, guys. Okay. So now we have the third data ingestion that we are going to do. This is what we completed: loans and customer data ingestion via the file, via the cloud storage. We taken it to the BigQuery, Big Lake layer, and the Lakehouse layer. The final layer is our Lakehouse layer. Currently, we have the data over, which is our maybe like the raw layer where we have the data into. Okay, or curated layer. Sorry, curated layer where the data is available into. We are yet to take this data into analytical layer, and that is a different story. Now let's move towards one more data ingestion. That is nothing but the exchange data ingestion. Okay. In interview, question is asked on schema evolution. Yes, Arivi. Schema evolution, we always see, right? We have seen it multiple times, right? You can just talk about that. But you can see even here also we are going to do the schema evolution. Right? Schema evolution is always an interview question asked. Okay, definitely you must be in a ready state. Maybe here you can see whether we can liberate some schema evolution or not. We'll go and see in this example particularly. Okay, fine. So I'm going to get some data about the exchanges, the money exchange and the currency information from some REST API. They are going to expose country-wise, state-wise, region-wise. What is the exchange value? What is the currencies they are using? How many people are using these currencies? These kind of information, country-wise, the population information and all, they are exposing in our in a REST API, in a web service API. There are some open web sources that is available, web services source that is available. We are going to collect that data via the REST API service we are going to use in our Dataproc actually. Here we can't go and use our BigQuery. We can't directly go and get the data into our BigQuery for this case and all. So we are going to use not our BigQuery component to get this. We are going to get this via the like Dataproc. Okay. So we are going to have the REST API interface created to collect the data from the external source. The REST API has been established as a web service, as a URI by some companies, by some external systems, where they are going to expose the data in a complex JSON format. We are going to evolve on the schema. If data is provided as a JSON format, we don't have to worry on schema evolution. Automatically, it will be evolved. But even whatever we have seen is a schema evolution so far. Arivi. If I'm going to add one more column in the data set, if I'm going to add some other column in this data, if I'm going to create this table, this day 2 data, right? This table contains how many columns? If you go and see, Arivi, you'll be finding almost how many columns we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. Now, I'm going to have the same loans data added into this table, into this data set location, where I'm going to add one more column into this loans data, loans 2 data. The data got evolved, let's assume. Loans day 2-1 or something like this. Okay. If you are going to get some more columns added, sample column or some other column called bank ID. Like this, I got some data added in this. From which bank the customer have got the loan. This data let me place into our cloud storage bucket. Right? Earlier, how many columns I had for this table available? For this data, we got how many columns available? If I remember correctly, 10 columns. That much. Okay, 10 columns. 3, 3, 6, 7, 8, 9, 10. Great. Thanks for that, Ranjit. And the Hindupriya. Now I'm going to recreate this table. Now what happened is this column number got increased from 10 to how much? 1, 2, 3 bank ID brought over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is even a schema evolution. Got it, Arivi? Right, Kumanan? Just a pretty direct schema evolution we did. Right? We did not do any work. It got evolved. It got added. Okay, fine. We can see that schema evolution everywhere when we use the data in a form of JSON or ORC, Parquet kind of data format and all. Let it be. Okay, we'll come back to that. By the way, after I see Hindu Priya responded, right? I had a couple of good news to share about a couple of our team members have got opportunities, guys. At least 4 of our team members have reached me in the recent last weeks and all. And I congratulate all of them. Harish, Hindu Priya, Ram Kumar, all these people have joined even the organizations. I meant to talk with Hindu Priya, but at least they got a couple of offers and they joined, including Ram Kumar is almost 18 plus years of experience. He got into, got almost 2 offers and he joined one of the company. He came to visit me at my home and we had taken photos and all together. So just wanted to convey you guys. All of these team members are from the weekend batch, right? I appreciate all of you guys. I wish us all of you guys a good career ahead, guys. Okay, including Hindu Priya. I'm not sure whether others are attending. Harish is attending or not. I'm not sure. And Ram is also not attending, but at least Hindu Priya is attending. Great Hindu Priya, keep going, right? And I know like how she put the effort and she got it and all. That is really greatly appreciated. This join with me appreciating Hindu Priya team. Okay. So let's move forward, guys. Okay. So the third activity what we are going to perform is ingesting the data, right, into our or ingesting the REST API data into our Bigquery lakehouse altogether into the curated layer. What we are going to achieve here is we are going to collect the complex JSON data and we are going to flatten the data, add some columns and all in addition to the data set. And we are going to ultimately perform some sort of curation activity on the data itself on the fly when we load the data into the curated layer. So we are going to do risk aggregation, right? Or risk categorization and risk aggregation. We are going to identify the multi-currency and the exchange segregation. We are going to perform population analysis on this REST API data that we are receiving from the source. Okay. So let's go and see. Based on the population, based on the country type, we are going to calculate the risk at the time when we receive the data itself. Okay. Let's go and see the scenario what we are doing here. So for that, we need to have our Hadoop cluster started. Our single node Hadoop cluster, I'm having it already stopped where I just did some sort of activities and all. I kept it in a stopped state. So what is the code base we are going to understand for that? So we are having something called an API load Pyspark program that I created, where we are going to do the data ingestion from the REST API. So we are having some REST API HTTP services enabled by some third-party systems. Where we are going to get the data related to the countries, the states, the currencies of different countries and states, including the region information and everything we are going to have collected from the sources. How much population the country has, what is the country system we use, the time zone that we are using, what is the continent he is belonging to, it's belonging to, right? When the start of the week happens in this country and all, the postal code of the country, and what is the currencies that is being used, the symbol of the currency that we use. All this information we are collecting from the API source, not of one type of currency alone, US dollar alone, for euro, for Singapore dollar, in Indian currency, Indian rupees, Canadian dollar, everything. So what we are going to do here, we are going to use Spark to, we are having a Spark program created with the Spark session creator, right? With the structure defined here, very importantly. I'm having the complete structure of this JSON object defined here. I define the complete structure of this JSON defined in this data set. Okay, so I want to take the name, common name, official name, native name, official name, common name, which is kept in this data structure. The name, common, official, native name, then the official name of it with their own language, and the common name of it with their own language of what they are using. Like this, every country's information I'm collecting like this, including the lat long and everything. Puerto Rico or whatever the countries that I'm going to collect the information from. So I'm defining the structure for that by using the struct type concept and all what we have in Pyspark. This is a bit time consuming process, but in order to leverage this kind of complex structure and all, I would tell you an idea of using not for the simple data structure, it is complex. You have to spend a lot of time to arrive this and all. Rather, what you can do, you give the sample data to our GPTs and all, to our LLMs and all, to our LLM models and all you can give, the chat GPT or whichever you can use to get this models identified, get this schema derived for you. By that way, you can reduce your time of or improve your the productivity of writing the code. But what you're supposed to do is we need to get the structure defined. After that, what I'm going to do, I'm going to iterate. I'm going to iterate on the URLs that I have created. Whatever the URLs that I have mentioned here contains the list of URLs. I'm going to iterate on that URL. I'm going to use a function called or a library called request library to get the data from the URL. I'm passing the URL as an argument and get the JSON object from the URL as a response. That response I'm registering as a JSON data. So that JSON data I'm going to extend and expand and make it available into my data set. I'm going to assign that into a data set, into a variable. That variable I'm going to register it as a data frame by applying the schema. So I'm converting a normal data that I received from the external source by iteratively inside the for loop. I'm going to get it iteratively and add it into this all data. I'm extending this JSON data, whatever I'm getting from different URLs and putting it in one variable. That entire one variable, whatever the JSON data I got from different URLs, I'm going to apply the schema, the data frame schema. I'm going to apply what I defined in the top, the complex nested JSON schema, restricting some sort of like log errors and all if I receive more than 1000 bytes in a string like this and all. I'm just defining some property to avoid unwanted error showing, because there is a huge chance more sized data can come in the web URL and all. Printing the data for just an understanding purpose. Then we are going to do the data loaded into the Bigquery table. Define the schema. Is it easy way you mentioned something? What? That I missed it. Take the support from ChatGPT kind of environments or Copilot kind of the GPT environments. You are with me? Like maybe how many of you are not aware of getting such kind of support, guys, from the LLM or GenAI availabilities in the market is now available, right? How many of you are not aware of doing that? Aware of making use of the chatbots and all? Anybody is there to say that you want me to show something related to that? However, we are going to see it in the next iteration. In another few minutes, I'm going to show you. Not directly going to the chat GPT. I'm going to call the APIs of our Google Gemini. We are going to use Gemini, not the chat GPT, not the Copilot of Microsoft. We are going to use the LLM model developed under the Google environment. So everybody are aware, I hope so, right? Correct? Okay, let it be. I'm going to load this data, the data frame, whatever I got, the raw data frame, which contains the complex nested JSON data and all, into a table called API raw table under the core banking data set. The core banking 1 data set, let's use. Okay, we are using core banking 1, right? Which is the raw layer. Core banking 1 data set I'm loading. Then what I'm doing? I'm doing the risk categorization and aggregation based on the regions. If it is Africa, I'm going to add a column called risk level in the data set. If it is an African region, or the population of the data is, or population of the people is more than 10 million or 1 million, I'm going to make the risk as high. Risk mitigation, risk aggregation I'm doing. If the population is more and the countries or region is Europe, then I'm making low risk. Or if it is not meeting this condition of the case statement, then I'm going with medium. I'm creating some data set with risk data like this. Then renaming the common name as a country, because I'm getting the name as common here in the data set. I'm not interested in seeing that name called common. Common they are giving for the countries. I don't want to see common as a country name. I want to see it as a country name itself. So I'm renaming the data set, whatever I'm having. Then choosing only the country name, region, population, and risk level, displaying that in the screen, and loading the data into the table called risk category table under the core banking analytics 1 data set. We have created one another data set, right? Here. Core banking analytics 1 data set. Directly I'm loading the data into the analytical data set. Let's go and see the data loaded after running this code. Then multi-currency detail segregation I'm doing. Multiple currency I'm receiving from different countries, different currencies I'm receiving. I'm exploding for every country. I'm creating an alias name for common name and all as country, and I'm bringing the currency value and the region and the population value I'm deriving from this data frame. Then I'm going to make the country code and the country and the currency name and the currency symbol and the region and all derived. This is the currency segregation we are doing on the complex JSON data. Storing that segregated country-based currency information in another table called currency details table. We are doing data ingestion, come data transformation, data curation, and load the data into curated layer or the analytical layer. Maybe we'll use this data for analytics later, or for further we may do analytics on it. So I can put it in a curated layer also. Let it be. We are doing the curation. So I'll go and write this data into the curated layer. This data also into the curated layer I'm going to write. The data I'm segregating, risk analysis I'm doing, or risk segregation I'm doing, and the multi-currency data segregation I'm doing based on the region. Then population analysis I'm doing. I'm calculating the population, the top populations. Here I'm doing the analytical results stored in the curated layer again. So I'm identifying what are all the rank I'm identifying for, applying the row number or rank function for, applying the row, the rank based on the population. Region wise, I'm doing the window operation to partition the data based on the region wise. What is the top population people? Those data alone I'm identifying by putting the rank and storing it into a table called largest country details. In an ordered fashion, I'm going to put these are all the top 1, 2, 3, 4, or top 1 across all the countries, which region has more number of population. That information I'm calculating and storing. These are all the data ingestion come data transformation and curation we are doing while loading the complex JSON data from the API. So the understanding here is what? How we can parse the complex JSON, how we can get the data from the APIs using Spark, how we can go and parse this data, how we can use some functionalities to address the structure type data, how we can perform some Spark transformation activities and all that we learned long back to access only the particular structure.common column, performing all the other operation, exploding operation, because it is in a list, it is in a list format, and getting the exploded data, right? And then categorizing the data into multiple tables. First of all, we are storing the raw data into the raw data set. Here, this is the raw data set what we have. In the raw data set, we are storing API raw table. Then we are storing risk category table in the curated layer. Then we are creating currency details table in the curated layer. Then we are storing large country details in the curated layer. Right? First, we will execute this code to understand what we are doing. Or if you want to really understand this code, how it works, particularly what Venkatesan is asking, Irfan, I don't understand how this complex JSON importing of data from the REST API is happening. We have to go and run a Python program to understand that. So we have to go to the command line interface, command prompt, start Python, either. Or we have to go and open our PyCharm IDE, whichever is kept over here even. Or what I'll do, we already have a cluster formed and running right over here. Let's go to the edge node of the cluster. Right, Venkat? We'll go to the edge node of the cluster. We have a cluster already started running. Okay. I can go and give Pyspark. So we can understand by running this code one after another. Right. I had to import the request library, which is going to help us read the content from the JSON object. Right. From the REST API. It is going to put a request on the REST API URL, whatever I'm sharing. So to understand only how the REST API call we are making, we have to understand what is this request is all about. The request is a library which contains dot request we have. The request contains get function and a lot of other functions available. So request I imported. I'm going to tell what? Hey, there are a couple of URLs I have. A couple of REST API URLs I have. You go and iterate on each and every of this URL or take any one of the URL. Perform an activity of what? Forget about this nested JSON and all. Perform an activity of get operation. Get of this URL you do. Get of this one URL at least you do. Get the US dollar data alone in a variable called response. Then you recognize that data as a JSON data. The response, you register it as a JSON data set. So this is containing JSON data, whatever I received. This is an interview question even asked. How do you go and read some JSON data by using a Python program? I remember some of you have told, yes, I got that question is fun. I'm going to add all of those JSON data, getting the data from multiple URLs, appended to a list. I'm appending all of them to a list. Empty list I'm creating. In that empty list, I'm extending this JSON data. Whatever the JSON data that we got, I'm extending that into an empty list. Now, the all data contains the first URL data, US dollar related country, using US dollar currency, that data is loaded into this list. Now I'm going to say what? Hey, get the another URL also. Get the euro information also. And I'm doing this looping operation. Following me in that? I'm doing this looping operation. So again, I'm making it as a JSON data. Parsing it as a JSON data. Extending that into the all data. Now I got how many elements in this all data? I got the length of 2 elements added. You got the other region data is also added. Like this, we are looping on every URLs and extending the data to a variable in a list format. Then that list, whatever we got, we are going to apply the schema, or without applying the schema, I'm going to do this. The data frame, it is trying to register this data into. Whatever the JSON data that we have in a list format, we're registering the data as a data frame. So df dot show is using the schema what naturally we got from the JSON objects, which is not fixed, which is able to provide me the data set, whatever and all available in the JSON, it is automatically parsing and getting. I wanted to define my own schema to only get certain fields from the data. So I'm defining my structure of what are all the columns I wanted to be parsed. So I'm defining my own schema even by importing all the libraries. All these libraries and all I'm importing in addition. And I'm defining the structure. The structure, I told what? I was not in a position to write this structure of my own. So what I did, I taken one JSON data from the internet. From this place, I taken one JSON data, one JSON element I taken. And I went to some environment like ChatGPT or somewhere. And I asked him to provide me this struct type. Like this I asked him to provide. I asked him to provide this structure type of the data what I'm providing to him. Maybe some small shorter data it is asking. I gave some shorter data and I got it added and all. That is a different story. So he is giving me the structure type, struct field and all for that. It is generating. Following me, right? That the JSON data I have given, so he given me this in a reverse way. Okay. This is what I was asking. You can seek the support of this kind of, but how we are going to seek the support? Not by taking our image and uploading and all. We are going to use our Bigquery to achieve that, or Spark to achieve that. That is the next iteration I'm going to take quickly, and I'll will close the session, guys. Okay. So let's take here. We are going with the Bigquery data ingestion of this entire data. So I'm going to take this API code placed in our cloud environment. This is what we are finally going to write into our Bigquery. So I have some folder created with this API code already in place. We'll see this API code, what we have just used right now, right? I'm going to do a Spark submit by using the Hadoop jar version, the GCS connector jar, Bigquery jar connection. All this I'm going to use. And I'm going to call our Spark program. Spark submit operation I'm doing to run this, whatever the financial data lake API load program. It is going to do what? Maybe it is going to load the data into some other data set. Let me not do that. We have this modified to load the data into which data set? So our curated one data set, right? We created a curated one core banking one data set, right? So let me modify this API load program in a different way. Let us run this code. I'm running this code. He's going to show parallelly what is the JSON data that I received, what is the transformation I applied, and how I got the currency data, how I got the country data, and everything. AP load1.py. I wrongly mentioned it as AP. Let it run. AP load1.py. Where it is telling the error, line number 180. I have this bracket close missed, it seems. Okay. So it's going to simply take the data from the REST API, iterate on all the APIs, push the data into our Bigquery tables of all this. In the core banking, we got the tables are getting added now. Yet to add, maybe let it add. Submitting the job to the yarn resource manager into this cluster. Let it run the program. This is a Spark way of data ingestion we are doing. There is no option we have. We have very complex JSON data, which is supposed to be collected via API service. So we are using Spark here or Python program here at least. So we got, this is the raw data. This raw data is now written into the raw layer of the BigQuery table. Let me refresh. So API underscore raw is the table we are supposed to get here. API underscore raw, we got the data. We got the raw data loaded in a complex format. This is for the raw data analytics customer will be using for. Then I'm getting the other data set. From the raw data, we are passing risk level, risk mitigation, risk calculation we are doing on the region wise, population wise data. Then we are identifying the population analysis across the regions. No, not population analysis. I printed it wrongly. It seems. We are having currency data, currency symbol, currency name, country name, and all this information, including the region information. And we are having the population data also. I don't think I have printed it, but at least you can see it here available in our data set. So the core banking curated layer we will go and see. We got currency details table. We got currency details loaded into the Bigquery table, right? And we got large country details data across different regions. What are the large countries we have, the customers we have? We will be using this in the subsequent environment, risk category data. For our other tables, we will be connecting this and all, and we will be making use. But for now, we are getting this data ingested. This is some way the complex data we are ingesting, including the risk value added, medium risk or whatever the risk level we are adding it, holding the data set. With me in this team, the completion of the third data ingestion activity, what we are doing here. Finally, we are getting these tables loaded with all these three types of use cases executed. And I did not mention this use cases over here, what and all we are achieving in the end outcome. I can mention it here also for your reference. Right? What is the final derivation? Or maybe you can add few of them over there. Okay. I'll go with one more use case, one more final use case in another 15 minutes, and we'll close our session, guys. Okay. Very interesting one. But this is not maybe like what to say, a very familiar thing for all of us actually. This is a very modern, maybe like functionalities. Basically, the way how the systems are going nowadays is we don't have to worry on the complexity what is involved internally. We wanted to simplify our life of getting something achieved. For example, I'm asking the chat GPT, hey, can you help me on getting something out of this? Right? We are going to a web GUI and we are doing manually and we are getting the result out of it. Why not we can go and use our built-in, basically why the people are very much preferring. You guys are seeing lot of the GCP related projects, GCP related or cloud related, at least you can consider Microsoft or GCP or AWS related projects are heavily coming into the market because of they are giving it as a suite. Especially if you see the GCP side, it is very much growing because of Bigquery. Bigquery, without knowing Bigquery, we can't go into a cloud project of GCP. But Bigquery says, I'm an analytical layer, I'm a data warehouse layer. I'm a data warehouse component of GCP. What our Bigquery is telling in addition, we have Bigquery ML available, Bigquery machine learning language model available. We have Vertex AI, artificial intelligence models available, which can be integrated with BigQuery very easily. You can go and do some data engineering work. Not only data scientists have to use our data, our models and all. When large learning model is coming into picture, generative AI is coming into picture. We are asking the AI to generate something for us, content for us. We are asking AI to generate. We basically give data to the AI and ask him to get trained on the data. Going forward, if the AI get the same kind of data, it will learn the model, it will understand that kind of data and start answer heuristically to us, saying like, I already learned about it. How we are learning about something, we are expressing the output of that. If we learned already about something, if somebody asks me some question related to that, we can able to answer them right in the right way. Hey, because of I learned this concept of data frame in Spark, I can able to answer you this question. Like this, we learn and we answer the people based on what learning we made. Same way, the models are already trained and kept ready as large learning models. Models means we will give some data, whatever is happening in our real life, and we are asking the model to get trained. That is how the data science models and all are working so far. But because of the recent evolution that happened in the generative AI, that is a bigger topic actually, but I'm just giving you a high level overview. We'll be engaging some generative AI based workshops and all. So sometime later we are going to engage in the next year, first few months and all. Prompt engineering or GenAI, LLMs, these kind of concepts and all. But however, for now you can consider we are going to apply some such kind of AI thinking and all, AI model thinking and all, with the predefined models that is already available in the library of our GCP environment. We are going to leverage the generative AI based solution for doing one activity in our banking system. What is that, we have some credit card information or credit card images. Let's assume the customers are returning their credit cards. Some credit card are not dispatched to the customer and it got returned to the banks, or the customer is printing a credit card. Credit cards too, or credit cards or debit cards or whatever the cards or images that they are printing for their customers, and they wanted to ensure whatever the value that they have provided is being printed correctly, whether it got wrongly printed or whether it got missed printing, not printed properly, the name or whatever I wanted to give in a credit card or in a debit card of a customer, that has to be intact with the expectation. It should not have any missed information. So for that reason, my source is going to send my credit card printing department is going to send all the credit card images in the form of PNG or JPG file into our cloud storage bucket like this. Like the credit card is going to looks like the bank name, then the card number, then the expiry date and the name of the customer. Like we have a couple of credit card images I have uploaded here. This is some other credit card. Few more credit cards I have uploaded here. Lorem Bank or something, I take it from the online and kept it over here. Some images of the credit cards. My aim is doing the image processing by using our generative AI prompting technique. What is prompting technique? Let me go and open the code and show you guys. You'll get some clarity. Okay. I'm going to connect with an external connection I'm going to create to pull the Google created Vertex AI model. Google have created some model called Vertex AI. The Vertex AI is an intelligent model to apply generative AI based solutions and all. It's going to help us return or respond with whatever the question I ask. Hey, Vertex AI falling under the Gemini, Google based Gemini AI, Gemini, people used to call it as, not Gemini. Gemini is our Tamil name or whatever the name, right? our regional name. But Gemini, they used to call it as. The Gemini based model, they are having already built in the name of Vertex AI in the Google environment. I'm not going to put any effort here. How they build that model and all, it's not my worry. My worry is only about how can I make use of that efficiently for my business solution. Pretty interesting thing, what I'm talking here. We are going to invoke that literally. How? Let's go and see. I'm going to use only our Bigquery to leverage that. Most of the data engineering work only I'm going to do here. So our aim is what you know, very simple guys. I'm going to tell somebody, hey, Gemini or Vertex AI, can you accept my prompt, whatever I'm telling you? Can you just receive that information from me? And go and apply that information in a form of program on top of the images that I have uploaded in the cloud storage. What I asked you to do, you know, here, go and extract the name of the customer, the bank name, the expiry date, the account number, whatever is mentioned in the credit card. Can you extract all those information? I'm telling by prompting, by doing a prompt engineering, I'm telling the model very clearly, I want this information from the card. Can you help me pull those information from the card and write it in a table? So the card, whatever I have given as an input to get printed, that data I will match with what actually printed in the card. You are able to get my point. What is the use case here? We are asking, hey, read this credit cards and all from the cloud storage bucket by using the Vertex AI external connection that I'm going to create in Bigquery. First, bring that model data into a model table. Then using the Gemini provision library presented in the Vertex AI environment, you call that API, you go and hit that API, apply the LLM model on top of that credit card data, large learning model. Already the Vertex AI and the Gemini have trained their models to say what? Google have trained their models to say what? If somebody is giving you a card like this, you should know how to read the logo of the bank. You have to know how to read the card number. You have to know how to read the person name. Every details from the card you read. We are doing what activity here? Are we doing any data science model here? Any AI model here? No, we are not creating any AI model here. We are leveraging the AI model to do what? Data ingestion. Ultimately, I'm telling, can you convert the unstructured data into structured data? Very simple activity what we are doing. But we are doing what? We are prompting. We are typing something, chatting something. That is called prompt engineering. We are giving a prompt to say, hey, can you go and use the model, apply on the credit card with whatever you already learned. I'm not teaching you and all. I'm telling, I'm not teaching you and all. You already learned and kept some brain created, right? Use that brain, and it's not just an image reading and converting to text. That's a major difference between that. Image to text conversion we can simply do. But what text has to go where is very important. We are doing a higher level intelligence here. We are not putting any intelligence. We are telling what? Take the column value and store it into the respective column. It's not so easy. Reading an image and converting to text is very easy by using some Python program or some library. That is easy. But understanding the image is not so easy. Our human brain and eyes can only understand an image. But computer is understanding that. That is called computer visioning. We are implementing computer vision here. We are telling computer, use your eyes to see the data. Convert the data into a structured format. If I don't use this model to do this work, I'm printing 1,000 credit cards per day, debit cards per day. I wanted to do a reconciliation. Whether the credit cards that I'm going to deliver to my customer is intact with what is expected. How much human effort is needed here? Able to understand, guys, what I'm speaking? We are going to implement this pretty interesting story. I have even uploaded my credit card and tested it works fine. Okay, let it be. We'll go and see this example, guys. You can add it in your this thing and all, but the interviewer will not be there to ask you the question on that because he don't know all this and all. Okay, keep that in your mind. So GenAI based credit card reconciliation we are going to do. Very simply, we are going to create one project, maybe core banking one. I'm going to create one procedure in this environment where I'm creating an external table only, returned cards or printed cards, any name you can give. From the Inceptez common bucket, you go and use the Inceptez Vertex AI connection that I created. First, I'll go and say, hey, Google, I wanted to invoke your Vertex AI based library. For that, I'm going to add an external connection. I'm going to connect to an external source, or I'm going to connect with a lot of these kind of libraries provided. So I'm going to say, what, hey, can you help me connect with Vertex AI on the external connection. Vertex AI remote models that is available in our Google environment. I'm going to say what I wanted to call that AI models, AI Vertex AI based models by creating a big lake table on top of it. I'm going to create a big lake table to access the Vertex AI models. I'm going to create some connection ID called Inceptez Vertex AI or whatever the name, multi-region or whatever the name is, IZ Vertex or whatever I'm just creating. I'm creating a connection like this. Very simply, my work is done. I'm going to use the API call. I'm going to make an API call even here also. But with the available APIs, not with every APIs I can do. Google is telling what, hey, Irfan, you know, I have given you an API for external connections. So we got this in us.inceptez Vertex AI connection creator. I'm going to mention that. Inceptez Vertex AI connection. Like this, I'm going to leverage this connection. Creating an external table, a big lake table I'm creating. Creating a big lake table to invoke or to call the Vertex AI model via the API, application program interface. So this time I'm not having the data stored in GCS storage. I'm going to call an external API to read the data from this image folder where I have a couple of images kept, credit card images kept. Seeing the data that is referencing by this return cards, not curated DS, right? I had to use the bank, whatever this DS, right, that we used. What is that? Core banking. So let me go and create an external table referencing to this. I'll go and run it separately, okay, one after another to learn it more better. Let me not run it as a SP. I got an external table created in the core banking environment, which is a external connection table, a big lake table I got created. It's a big lake table. What is big lake? Somebody asked it, right? You're able to understand? This table is going to refer to the GCS storage file, which will be identified by the connection called Vertex AI. The Vertex AI libraries I'll be calling and applying on this data. I'm going to apply on this data. Using that Vertex AI, it identified from which URL. It is telling what, Irfan, you know, I'm giving you this data. Give me 5 minutes, guys. We'll finish this, okay? I'm giving you from which URL I got this data. From which cloud URL I got this images. What image type? When it got generated? What is the size of this image? What is the hash value of this? What is the updated timestamp, and all this information I collected. What is the metadata name? All this information he collected. What is the value of this? And all it is collected and kept it ready. Now I'm going to say what? Okay, the file you have read and collected in a whatever the hashed format. You are reading that image in a hashed format. You are able to read the 3 images. I'm not going to get anything out of it. Just it's a binary data. Now I'm going to say what? Hey, can you create a model table in Bigquery itself? Can you create a model table? Credit card computer vision model table can you create with the help of the Vertex AI connection library? What I created with the remote connection, what I created using the GenAI provision endpoint. I'm going to say this connection has lot of libraries available. I'm going to use one type of library called GenAI provision library, professional vision library, computer vision library. I'm telling like that. Computer can use your eyes to see the data. Like this I'm telling. Model table got created. We got a model table got created. Okay, what it is telling is, Irfan, this service account does not have an access to perform a call. So you ask your administration team to give an access for this guy, for this particular API. You ask him to give an access, for administrator to give an access. So for this project, I'm going to say what? A grant access for this guy. With what role? I'm telling. He's throwing an error. Give a permission of Vertex AI user role. So I'm going to say what? Hey, can you give a role called Vertex AI based role? Vertex AI user or an administrator role I'm giving. Let it be. I'm going to get that access from my administrator, telling like, hey, I am using Vertex AI in my project. So can you please give me the access for this particular service account? I'm going to request that and get the Vertex AI access to hit the model, the GenAI model. Vertex AI admin role, storage admin, and editor. All the roles I'm giving maybe. I'm going to get all this role given. Let it be. Need some additional privileges to give. So I got the model table created. Model table created. Okay. This model table also we can't able to do anything. We have a model table created. The data science model table, AI model table created with the help of the Vertex AI library, where we used GenAI provision, particular function inside that library we used. This is like a package. Inside the package, we used a function called GenAI provision function. Then what we are going to do? We are going to create our normal table. A regular managed table we are going to create. And we are going to use we are going to bring only the URI and the ML generated text LLM result we are going to collect from this model table by using the generate text function inside my ML library. In the model library, I'm going to use my generate text function. I'm going to ask, hey, Can you use this model table where the data is referenced and all, where this Gemini provision libraries are referenced using that model table what I created? Can you go and access the data from the returned cards table what we created in the top, which is referring to these images and all? Can you help me go and get the data from the table? The temperature is the accuracy level I can mention. Don't worry too much on this. 9.9 means higher accuracy, lower accuracy. Whatever the data, even I don't wanted 100% accuracy, we can define that value here. We can adjust this value according to the data that we receive. But the very important point here is, see this. This is called prompting. I'm asking in the chat GPT, hey, can you give me this or that, like that, right? I'm going to ask the same thing here. Telling what, hey, I have some data in this returned card tables. The data is read as a image data and kept it in this table in a binary format. Can you go and help me apply this prompt from the given image stored in this table using this computer vision model what we created? What is the number in that file, in that particular image? What is the name? What is the logo? What is the date in this format? Answer this in a JSON format. Give me in a JSON format with the keys as credit card number should be string. The number has to be as credit card number. And the name should be in string format. Logo should be in string format. Valid through is in a string format. How long it is valid? How long this card is valid? As a prompt, can you accept it from me and create it as a JSON output? Like this I'm telling, and get the data stored into this table called computer vision table. So it is going to create some JSON data by reading those images into this table by using my prompt. The important factor is how we are using the prompt to help my model read the data. So the model table is going to be used in the background. This model table is going to be used in the background to go and read the data from this table, apply the model on top of it with the prompt what I mentioned. So multiple things are happening. The model table what we created, model table we created above, is helping applied on the return cards table data where our images we have referenced using my Big Lake return cards Big Lake table, right? And apply the prompt, the text I mentioned. I prompted and store the JSON result into the credit card computer vision table. There are multiple things involved here. Agree? Agree, guys? Able to understand at least? I'm not teaching you the prompt engineering or nothing. Making a very simple way to make you understand this. We got now the JSON data loaded, the complex JSON data loaded. Hope you are with me in this, right, team? I mean, this is learned by spending a lot of time in general, but I'm taking a very short span of time to make you understand. So until what I wrote, I hope you understood. Now we got the vision table with all the JSON data identified, but it looks a bit complex. I'm not in a position to use this very directly. You can see the JSON with credit card data. The credit card number is loaded here. 1234, 1234, 1234. Let's see this example. We got this data loaded, you see. 1234, 1234, 1234. John Doe, Lorem Bank, valid through 12/9. Even the image is not so clear. John Doe, 12/9 valid through. Lorem Bank is the bank name. It is able to parse the data. This table just now we got created. Now I'm going to tell what, hey, okay, don't have the data in a JSON format like this. Can you help me do some standardization on the data? Final result into structured, standardized table. Something called credit card structured to verify. We are just simply loading the data from that other table by using JSON functionality, JSON query, regular expression replace of unwanted blank spaces and unwanted strings and all I'm replacing here. If you see here, the data is not so appealing for me. It has some blank spaces and all on the data. In the credit card number, you have some blank spaces and all. I'm removing all those unwanted things, making this table more clean, standardizing the data and converting the data from semi-structured to structured. So unstructured to semi-structured to structure we are converting. Now we can very well go and see this data clearly mentions what we have. What is the URI where we got the data from? What is the credit card number? What is the customer number name? What is the bank name? Valid through how long? The other file and all whatever I have is not, seems to be like a right file. It contains some numbers alone. There is no valid data is present in the other card and all what I have here. Just only the number we have. So it is only getting the number value, not rest of the data it is coming up. Only the number is coming into that next data set. Like what we have in the data, it will come up. Guys, it's a good, interesting use case. We are doing data engineering only. We are doing data ingestion only, but we are using the power of whatever people are creating the hype like GenAI, LLM, artificial intelligence and all, right? This is what I wanted to show you, something related to this, relating to our project and use case. I hope you got something identified here, right? So nowadays the things got reduced in such a way to use the models. That's it. So this will give you an idea of this does not require intelligence. And one more thing I wanted to ask: what is the more work we are doing here? Data engineering work or data science work? Tell me. We are creating a connection. Data engineering work. We are using only a model which is provided by somebody. This is the only place where the data science is coming into picture. AI is coming into picture. Rest of all places, this can be done by everyone. The prompting can be done by everyone. This is just to require an English knowledge. If I know how to type English much better, and how I wanted the data. If you ask a data scientist or a AI engineer, he don't know about what is the JSON, complex JSON, what is his regular expression replace, JSON query means what, LTrim and RTrim will do what, these kind of things and all, he's not much aware of. He don't want to target on those and all. But we knows about, okay, we are doing some unstructured data to semi-structured data to structured data conversion. Simply what we can do, we can run a SP to achieve this now, going forward. I'm going to create it as an SP and I'm going to see the data loaded into my table. That's it, case. I know like we are on top of the hour. I'll share you this presentation along with the code attached to this presentations. I'll share. You can directly go and just create one cluster in your Bigquery environment. If you have one, create the cluster by using this cluster creation command. Go and run this SPs and the data and all, play around with it. So you can able to say, now I know how to ingest the data from the source in all these aspects: currency data, loans data, customer data, credit card image data, parsing. The payments, transaction, accounts data, how we are going to parse, how we are going to process. We see it in the, that includes both Dataproc and Bigquery. We'll see that one in the subsequent week. Okay. Account transaction, analytical model, all these kind of things and all, overdraft usage, foreign currency or low balance, flagged customers, excessive fees, payment analysis, merchant payment analysis, all this we'll do in our subsequent learning. Okay. Next week, one more time, we'll have a session and complete data ingestion, then data curation and analytical, and all the other part of the project will execute this. Okay. Yes, I'll share the videos, guys. By today or tomorrow, I'll share. Actually speaking, like 3 weeks, I'm running like anything, guys. Even today, I'm not in I mean, like right pace to take this session. Even I thought of canceling, but I don't wanted to cancel. I executed some way. I was running from morning onwards. Morning session after I completed, immediately I was supposed to drive somewhere around 20-25 kilometers, and I had to come back. And I'm coming back and taking the session immediately in 5-10 minutes of time. So for the past 3 weeks, I'm running like this for some reason. Some reason is popping up, and I'm supposed to run, including my office work also. But one great thing, one what to say, like uh, maybe like a happy thing to convey to all of you is I got a very good award or a big award in the last week globally, right, in my organization. So that one thing I just wanted to convey. I don't wanted to maybe like in fact do that much effort of getting the awards and all, but someday I got it. Like I was not much interested in getting that, in fact, because I'll get more work and all. I'm not able to manage already all this, right? But however, I just got it. Okay, just to convey that thing to you guys. Okay, fine. So I'm expecting the same from you. Expecting the maybe like all this kind of maybe like what to say the great news is from you guys soon. Okay. Hari, I think you are there, right? I was talking about, I was maybe like telling about your recent offer and all, right? Um, you are there, Hari? Okay, that is fine. Okay, guys. So otherwise, have a good week ahead, and we'll meet in the subsequent week for covering the rest of the part. Okay, I'll share you all these guys by today night or mostly by tomorrow. Definitely, I'll share. Okay. Yes, I will share in our group itself. So he will also respond, right? You can talk with them and also. Okay. I'll share that. Okay. Otherwise, thank you guys. Have a good week and day ahead. We'll meet on mostly next Saturday, next Sunday. Sorry. Okay. Anything, Bala?
So, can I have a couple of minutes regarding setting up
Not
VM,
Bala. What is that regarding?
setting up VMware issue? I'm facing some VMware issue.
VMware, you have some problem or what?
Yes, yes, so
Okay.
I have
Can we do one
to
thing, Bala? I mean, actually, I'm just going for somewhere out to catch up one thing, actually. Okay.
sure, sure.
Closing that. That's the reason. When I thought of closing by 8:30, but I was not able to. Maybe like we will connect again either tonight or tomorrow. Tomorrow, what time will be available? Evening, can we connect?
Yes, yes.
Okay, ping me, please. We'll connect. Okay.
Fine, fine.
Fine then, Bala. Okay.
Sir, can you please send the PPT, sir? I have an interview Tuesday. You can send.
I sent you, right, that other one. Which one you are asking? This one, huh?
This one, sir. See,
Yeah.
this has more details. I can.
Yeah, this PPT I'll right away send.
Yes, sir.
And the code I had to attach, maybe I'll send that code next as one more. Or I'll send this PPT to you alone now. Okay. Yeah.
Sure, sir. Sure, sir. For the interview only. Sir,
Yeah, got you. I know. Yeah, come on. I know. Okay. I'll send you right. Okay.
Sure.
Yeah. Fine then. Thank you. Thank you all, guys. We'll meet on next week mostly. Okay. Thank you, guys.